zoom. Perquè a mi no m'arriba res per matriu. I si intentem fer la sortida cap allà i què? Ja està.
Hola, bon dia.
Hello and good morning.
Benvinguts i benvingudes.
Welcome. Welcome to this session on computer science for all, how to coexist with technology in the field of innovation and education. We're very pleased to share this session with so many of you from different backgrounds, different organizations, different entities. It's so thought-provoking to have you here. It's so nice to have you here, and I am sure you're going to be enjoying a lot today's presentations on different experiences from public institutions, academia, the third sector. What bonds us here is our concern around IT skills for future generations. This is what bonds us here, as I said before, this concern, this willingness to work in favor of IT skills, digital skills, high quality education, a diverse education, because of course we are all different and we all have different ways of learning, and this is why it's very important, and one of our key values is to share different strategies, different ways to develop IT skills with children and youth, be it within school frameworks or in other environments, in the family environment, in leisure activities, etc. So, having said that, thank you very much to all of you for being here.
Jo, d'entrada, us volia fer una mica, us parlava fer una mica d'entendre el context
I would like to try
dels
and understand a little bit
diferents
better
col·legis.
this
M'agradaria saber que us està
audience,
passant,
this public. I would like
eren
to
diputats
get to know you a little bit better, if you
és
agree.
dilluns,
I
per
think this will
calor,
help us wake
i
up. It's
estem al
Monday morning,
juliol,
it's
i sí que
extremely
sé que
hot.
la meva família apunta
We
molt les
are
vacances en esta
about
època.
to start
Vale,
our
primer de tot
holidays, so yeah.
preguntar-vos,
My first
qui de
question would be,
vosaltres
who
està estudiant
amongst
o té
you
un ordinador,
uses
un mòbil o
computers,
tal?
laptops,
Dues
tablets,
preguntes.
and smartphones?
Pregunta al revés,
I
qui no
could
fa servir normalment
ask it
mòbil
differently.
o
Who
tal?
doesn't
Veus,
use a
són
laptop
poques
or
o
a
bé persones que
smartphone?
no fan
I'm
servir mai
guessing you all
l'ordinador o bé
use
tal.
smartphones,
O,
smart
vale.
devices, etc.
La
Good.
següent pregunta
So the
és,
following question I
aquí
have
ja
for you,
una mica més
and
en
we're gonna
temes
scratch in a little bit. We're gonna dig in into the
és
topic. Who around
informàtic, també
you or
instal·ladors
who amongst
de
you is an
sistemes,
IT expert, an
telecomunicacions,
IT
tècniques
manager, or you
d'informàtica o
have perhaps
telecomunicacions.
undergone
He
IT
estudiat o de formació
studies?
professional.
It can also be a vocational training
I
certificate.
think there should be somebody else between this. I think you. So, some pocas, molt poques persones aquí
So very
realment
few
tenen
of you
accés a
actually
computador,
come from these
utilitzen
STEM
dispositius
careers,
digitals.
but we all use
La següent pregunta
digital
és, més
devices.
enllà d'haver
And the
estudiat
following question would be,
informàtica o
beyond having
telecomunicacions,
studied
hi ha molts
IT
altres contextos
or
que podem trobar on podem
telecommunications,
aprendre a programar.
it is clear
I
that
amb
there are
això
many
vull preguntar-vos,
contexts in
who
which we can
sabeu
learn to
com
program today.
programar
My
per
question would be, who in
Scratch,
the room
àrees de
has
programació
programmed through
visual
Scratch,
o programació
through
Python, o alguna cosa
visual
així.
tools, any
Aixequeu mans.
language? Please raise your hand
Veieu?
if you have
Aquí el dibuix
programmed.
canvia
See,
molt.
the picture changes quite
De
dramatically
les
here.
persones que han estudiat la
Three
carrera, només
out of you
49% de les persones que som aquí
studied IT, whereas
en algun moment ho
50%
hem
of you
fet
have programmed at some point
personalment o no per
personally.
estudis en aquest àmbit.
I
Anem
believe that
trobar
there's a clear
informació
lack
més
of
continguda sobre, a part de
studies
quantes
in
persones han estudiat
computation
sistemes
and in
d'informàtica i de
programming,
telecomunicacions i semblants, quantes persones saben programar? Perquè realment
because
a moltes
today,
altres
in
carreres
many other
s'ensenya com
fields, in
programar
many other
i hi ha molts
studies,
altres contextos on
there's
no
training
s'aprenen a
on
programar,
programming,
molts
and there are many, many different contexts where we can learn how to program, not only in university. So the following
el següent
question
factor o
or
el
factor
segon
or element
que
that has
podem
to be
portar i que
underlined
nosaltres
here
avui és el lloc on ens hem trobat.
is the place where we have met, this venue, the social hub of Fundació Bofill, which, by the way, we would like to warmly thank the Fundación and Hector and Julia. Thank you very much for making our life so easy. Thanks for organizing this meeting. And by the way, I would like to hand it over to Hector for him to tell us a little bit more where we are and what is the link between this foundation and IT skills. Thank you very much, Martina. It is amazing for us to host you, to host such an amazing entity with such a long-standing background in this field. Well, we are new players in the sector as a foundation, and let us be bold and honest here. Here in this foundation since 1969, we have been working for a fair world. Our main aim is social transformation. And since the COVID-19 pandemics, we have realized that education in the following years is going to have to focus on the digital, otherwise the inequality gap will broaden. We are, well, most of us are political scientists or sociologists, so we know nothing about technology, but we will know that technology is going to be a node of inequalities unless we promote technology and unless we understand technology as a lever for new opportunities. Today we'll be reflecting about computational thinking, which is a very important lever. So it's very nice, it's amazing to have collective and surrounding entities here in our social hub. Our social hub, this social hub, has been refurbished 1 year ago only, and well, many other entities have joined us. So again, our main aim is social transformation and education, and we little by little gather entities with a like-minded aim. The foundation sits in the third floor. We work in the field of promoting equality of opportunities, etc. This building in the past used to be a pasta factory, a spaghetti factory. Quite random, but again, I believe today's purpose, this building's new purpose, is amazing. It's to be a forum for change makers to meet, and I believe that us here in a very warm day in July means that we're passionate about what we do and that we are change makers. Later, I will tell you a little bit more about the aim or the activities that we implement here in Bofill Foundation to combat social inequalities. But having said that, welcome, welcome, and please feel free to get in touch with us again if you want to organize other encounters here. We have organized hackathons in the past, so feel like at home. You're most welcome. Just drop us a line, and we'll be very happy to host you again. Martina, let me hand it back to you, and let's get started. Thank you very much, Hector. So, in this project, Computer Science for All will have three speakers, Luis, Inés, and Phil. Let me briefly tell you a little bit more about the background of the project and the different entities that belong to the project or that compose it. Computer Science for All aims at developing IT skills for all, and it stems from UNSICO, which is a non-profit from Portugal, which is composed by teachers and academic representatives, so to speak, who bonded around the aim to working as to develop a methodology to promote IT skills in schools, in high schools, and in universities. The approach of the project is a very holistic one, which aims at, again, promoting an innovative pedagogy in order to ensure the deployment of IT skills amongst students from different ages by defining very specifically learning outcomes. And this is what Ines and Luis will tell us a little about. Ines is the executive director of INSECO. She has a master's in math by the University of Oporto. Luis is the co-founder and president of INSECO. He is an IT expert and a teacher, a passionate teacher. And amongst them, they will tell us a little bit more about the outcomes of the project, the challenges it faces. The second entity is the Open University. The Open University is the oldest open university in the world, a very large organization with more than 50 years of history, and they have trained thousands of students, mainly from the UK, but also from different parts of the world, because it's an open university, and thus access to it is very easy. And they have a lot of online programs, and this is why they promote participation around the world. Phil will be sharing his experience. He worked in schools for more than 10 years, teaching pupils IT skills and computing education, and then he moved to Open University, where he developed a very holistic and cross-cutting vision in the field of IT in the UK. He will tell us a little bit more about this program, his experience of working in this program entitled Computer Science. No, Computing at School is the name of the program. Yeah, Computing at School. We believe the program to be extremely timely for the situation here in Catalonia, because it has a very important push of IT skills in the academic curricula. So again, we now know two of the partners of Computer Science for All. The third one is Collectic, which is a Catalonia-based cooperative. We are seated in Raval here in Barcelona, and we have been working for 30 years for social transformation on the grounds of technology. We have always understood technology as a tool, and we know that this tool, technology, or the diversity of tools that compose this concept called technology, has to be placed at the service of humankind, so that we can improve quality of life, so we can improve life in general through the use of technology. Our expertise, our contribution to the project is working in after-school activities, leisure activities. So I will now invite the three speakers to the podium, and I will hand it over to you. Thank you and welcome.
Tina? Okay, so it's
the first slide for your presentation.
Martina, what time should we to finish?
You have around 40 minutes.
Okay, starting
30?
from now?
Between 35 and 40.
Okay.
Okay.
From now. Yeah.
Okay.
Okay. Falta a sincronização, não é? Okay. I see. Okay. Well, buenos dias. Bom dia. Good morning. It's a pleasure to be with you here. So my name is Luis, as Martina said, and thank you, Martina, for the presentations. Inês is with me as well. We'll talk about several things, but most important is to share with you everything that we have done until now, okay? And in particular, what we are doing here in this project. Okay, so this Computer Science for All is an European Erasmus Plus project, which means that the main goal is to focus on adult education. Okay. Of course, that we'll be talking mainly about students and how should we teach computing to students, but the Erasmus, and this project in particular, aims to talk and try to teach adults in terms of what they should learn in order to teach students, okay? And that's why it's so important to have in our consortium Collectica, Open University, and ourselves. So ourselves, we belong to ENSICO, okay, a non-profit association, that is trying to create an entire program to teach computing in the first 12 years of education, okay? But in terms of Erasmus and in terms of European politics and so on, it's not only important to talk about formal education, but also about the combination of formal, non-formal, and informal education, okay? And so, that's precisely because we are nowadays talking again about how should we combine these three things, that I will start this presentation going backwards, okay? So I don't know if you would like to travel in time, but we'll go back to 400 before Christ, okay? We are talking about Plato, we're talking about classic antiquity. At those times, these people were thinking about what should be the fundamentals of knowledge. And when they were thinking about this, they were thinking about the trivium, and also about the quadrivium. And the trivium means grammar, rhetoric, and logic. But if we put the quadrivium also on this equation, we are then talk about arithmetics, we are talking about geometry, we are talking about music, and we are talking about astronomy. And it's really, really interesting to see how all these people were thinking about abstraction, about math, okay? Because when we are talking about, for instance, quadrivium, they were thinking like this, okay? We have numbers, and numbers are an abstraction of something. Then we have arithmetic that deals with numbers. Then we put numbers in space, and we have geometry. Then we put numbers in time, and we have music. And then we put all these things together, and we have astronomy, which means numbers in space and time. This is wonderful, okay? And so, now back again to the quadrivium. When we're talking about grammar, rhetoric, and logic, nowadays, we are talking about learning mother language, Portuguese, Spanish, English, whatever. Then we are talking about logic, we are talking about mathematics. What about rhetoric? Okay? One thing is for sure, that we really need to know deeply how to communicate with each other. And that means that we really need to learn well our mother language. So we are talking about communication, okay? When we are a baby, that's the first thing we try to do, is to communicate with our mother, with our father, whatever. So we really need to know and to deal and to master our mother language, okay? And then if you want to go to other language, that's okay as well, of course. At the same time, we also know now that we are in an era in which we communicate in several ways, that all of us know that communicate, like we are doing here, is very powerful. Okay, so when we try to share something among each other, it's really important to communicate well. Okay, so mathematics is really important, and why? Because it's also a language, but it's a formal language. Okay, so we have a natural language, the one that we learned from the very beginning, and then we have a formal language. And why is this important? Because we are now talking about computers and computing. And in order for us to deal with computers, we will also need a language. And so, when we are talking about rhetoric, we also know that all the advances in technology and so on changed a little bit, well, not a little bit, a lot, the rhetoric. Because we can communicate in different ways, in very different ways with each other. So, when we are now talking about rhetoric, we are talking about human-human interaction, as always, but also human-machine interaction. And when we are talking about human-machine interaction, we are talking about programming. And when we are talking about programming, we are talking about using a language. And which language are we talking about? A formal language. And what is the formal language that we know a lot about? It's mathematics. So, that's why we are now talking about the new trivium. Okay, so we at INSICO, and also we are sharing, of course, all this also with this Computer Science for All consortium and with all of you, is that we are now trying to share with everybody that what we really believe that is happening now, it's that we are really talking about a new trivium. And this new trivium keeps the mother language absolutely core. We are talking about mathematics, but in terms of rhetoric, we replace rhetoric, or we extend rhetoric with computing. Okay? And so, because precisely we are not only talking with each other, but we are also talking and dealing with machines. Okay? And so, that's why we are creating an entire K-12 program from scratch. Okay? We know a lot about computing, we know a lot about mathematics. We are always inspired by others, like, for instance, Computing at School in UK. But, in fact, we are trying to put lots of creativity and lots of inspirations or lots of emotion in everything that we are trying to do. Okay? And so that's why we are more focused in concepts rather than in technology. Technology is just a tool. Don't forget that. Technology is just a tool. We need to work on the concepts. And when we are talking about computing, we are not talking about technology. We are talking about knowledge. The knowledge that we built in terms of everything that we need to explore a machine. Okay? And so we'll tell you a little bit about our story. Inês will also guide us on that story. And these scientific syllables that we are working on is built on top of math, physics, and so on. So are these the key areas of knowledge that we are dealing with? Okay? So mother language, mathematics, physics, all those scientific areas that we are trying to, somehow, to combine in terms of syllables to teach computing to young students and also, of course, to adults. Okay. So, Inês, now stage is yours. I think you will need this.
Thanks. Okay, so I'm just going to tell you a little about what we teach our kids and youngsters in general, because our approach is quite different from the usual ones. So in Portugal, we have 4 stages in mandatory education. The first cycle with kids from 6 to 10 years old. Then we have the second cycle, kids from 10 to 12 years old. The third cycle, kids from 12 to 15 years old. And secondary education, which goes from 15 to 18 years old. So in the first cycle, which comprises 4 years of education, our main goal is to tell stories. Okay, so we create these wonderful stories with fairies and princesses and monsters and all of those enchanted things that a children's story usually has. And subliminally, we put some computing concepts there. So they are learning without realizing that they are learning. And they create these amazing emotional bonds with the characters that appear in the stories. And these characters have always something to do with computing. We like to tell the story of computer science from the beginning. And where does it all come from? So first we need to understand what is a computer and what is its language. And you probably know that a computer works with binary language, so he only knows what is a 0 and what's a 1. So it's this language of zeros and ones that we need to understand in order to communicate with a computer. And we have, and when we are doing stuff on the computer, some zeros are changing to ones, some ones are changing to zeros, some zeros remain the same, some ones remain the same, but all these transformations are happening. So ones become zeros and zeros becomes ones, and that's all these mess of zeros and ones inside the computer. And we have, for instance, two characters in the second grade called Flip and Kip. So Flip is basically an elf that transforms ones into zeros and zeros into ones. So it represents a mathematical function that maps 1 to 0 and 0 to 1. So it basically flips. And we have another character called Kip, which is lazy, so it just maps 0 to 0 and 1 to 1. So it's the identity function, mathematically speaking. So we are already talking about very sophisticated mathematical concepts without students realizing it. So we're talking about a 7-year-old who already knows what a function is and does. So we're quite glad of what we're doing. We also play around with these boards that they have like black and white pieces that represent the zeros and ones. And so when we teach bitmaps, which is the way that images are represented on a computer, kids manipulate these pieces and they actually use their hands and boards. So we don't rush into going into computers very early. We want them to play around, to feel comfortable about these computing concepts. Computers come later, technology comes later. So there's no hurry, okay? We think that there's no hurry to put kids when they're like so tiny already with the tablets and computers. Otherwise it'd be like an overdose of technology. But they will eventually go to the computers and write small programs. So in the second cycle, we're talking about kids which have between 10 and 12 years old. They start using more intensely computer resources, but we also, we still focus a lot on learning without computer resources because we think that the knowledge sticks better. However, we start delving deeper into how programming languages work, so they actually start writing their first computer programs once they have acquired all these background knowledge and important concepts regarding computing. And we also establish more explicit connections with mathematical concepts. So before, mathematics was always there, but they didn't know it. And now they are more aware of it, that it's all math walking around. So this is a picture to show that all our students are very eager to learn and they love asking questions. They are not afraid of asking questions because we really want them to participate, and making mistakes is okay and we all learn from each other. So we try to have a very positive and open mindset, and for us, creativity, imagination, participation is the most important thing. And then, you know, when we take them to the computers, we use a web-based environment called Jupyter. And the first programming language that we use is Haskell, which is not very common. We never use Scratch, for example. We go straight to a text-based programming language. But it works wonders. It really works because when they go to the computer, they already know so much that they already know what they want to write because they're used to do it on paper. So when they go to the computer, they write the program and it works perfectly. Because when they write it on paper, they have to write it correctly. They cannot, you know, go on a trial and error until it works because the paper is not interactive. Then in the third cycle, they actually start programming a lot more. This explicit connection to mathematical functions is even more explicit. And then we also start collaborative programming using advanced programming editors instead of a web-based environment. However, I must say that our project is only like 3 years old or something. So we haven't yet worked with kids in the third cycle that already have these 6 years of computing beforehand. So this is what we think will happen, but we haven't actually tested this out because we are only 3 years old. We're babies, basically. Okay, so now we are going to talk about CS for All and this Erasmus Plus project and what we did and what the results were. So Luis, the stage is yours again.
Yeah, but I think, the most important thing now is, okay. Okay, so just a few notes related with everything that Inés has said. So repeating what Inés has just said, okay, we are just a baby. Okay, so we are doing this in this land. We have started this 3 years ago, okay? Of course, that behind us, we have lots of experience, academic experience, okay? So we have, for instance, I've been a teacher at university, okay, teaching computer science and informatics in general. Also very important is to share experience, okay? So collected a lot of experience, computing at school, UK, as you will also hear today after Phil's presentation. Has a lot of experience in the field, but again, we are just trying to put all our convictions on top of the table, okay? And as Inés has said as well, imagination, creativity, and so on are for us key factors in order to teach students and how to deal with technology, okay? So you need to learn lots of these concepts, lots of these things, and then you will see and you will use technology the way you should. So, in terms of, again, the Computer Science for All project, okay, so as I have told you before, so I'm talking about adult education. As you all know, okay, so nowadays the most usual thing is to go directly to technology, okay? To go directly to programming. We are not doing that, as Inés has said, just because we think that before that we need to learn lots of things, okay? And when we are talking about a programming language, we are not talking about beginning at the start, okay? So we are talking about putting the knowledge in a very high degree, which in our case and in our view, it's not the right way to do these things. The other thing that is important just to summarize is why are we working and using the functional paradigm, okay? So as you know, there are lots of programming languages. There are several paradigms in terms of programming languages, but we are using functional. And why? Because with the functional programming, we are creating a direct link to what students are learning in mathematics, okay? And that's really important because we put computing in the middle of all the knowledge that students are acquiring in mother language, when they are learning mother language, and when we are learning math. So, in a more general sense, when they are learning languages, okay? The other thing is that when we are now going into the Portuguese third cycle, okay, that also means is where we start, for instance, working and dealing with different programming languages, eventually different paradigms, like object-oriented paradigms, and that's why, for instance, with the Open University, we are also trying to do some experiments using Python. And Python, as you know, is a language, a very popular language, but in fact is an object-oriented programming language. Also, of course, works with lots of things that comes from functional paradigm. But again, we really think that it's more sophisticated to work with the object-oriented paradigm when we compare that with the functional program. And that's why we are starting with functional first, and then we'll go to the others. With the Open University, we are precisely doing that, and they have lots of experience around the world using Python and teaching adults to use Python to teach computing to young kids. And so that's precisely the kind of experience we are talking about. With Collectica, we are also sharing lots of the experience, because for instance, when we are talking about Scratch and all those experiences, we are also trying to get all those feedbacks and so on from the Collecti experience. Collecti also works with diversity of people that are trying to know how to learn things related with computing and with technology. Okay, so that's why, and again, talking about we are just a baby, we are just trying to get all these experiences, all these feedbacks in order for us to know exactly what we should do when we are talking about an entire K-12 program. So again, Inês, back to you, and so we'll now talk about what we have done in this project in terms of deliverables, okay, work packages. We will be talking about webinars, we'll be talking about blended mobilities, we'll be talking about intellectual outputs and conference like the one we are doing today. And so, Inês, back to you.
So we had 4 webinars and 3 blended mobilities, and I'm going to tell you some of the contents that we spoke about in those webinars and the blended mobilities. So regarding the webinar and blended mobility of the first cycle, so we're talking about kids between 6 and 10 years old, we essentially, talked about the binary language. So binary codes, binary matrices, and then also very important transformations. So it's important to know how to represent data on the computer using zeros and ones, but it's also important to know how to manipulate that data. Otherwise, nothing would happen. So the concept of a transformation or a mathematical function is very important, because it's like we need to move those zeros and ones around. And we also talked about binary image representation, as in that picture you said, where the kid was with a board and putting those pieces down. And one of the topics that we teach our second grade students then, and that we showed in this first webinar, was the Braille alphabet. So Braille is a system used for blind people to understand text, and each letter is represented using a grid with 6 dots, and the dots may be raised or flat. So you must have seen Braille on elevators and all of that, so you pass your finger on. And basically, we can represent a raised dot by a 1 and a flat dot by a 0. And so each letter is represented by a matrix with 2 columns and 3 rows, and each cell has either a 0 or a 1, because the dot may be raised or flat. And so here we have a binary representation of the letters of the alphabet using the Braille system, which was the first binary writing system ever, okay? So binary was not invented for the computers. It already existed before. Then here we have flip and keep that I showed you before. So they represent these 2 mathematical functions, now written in a more explicit way. And we may use them to transform binary codes that represent letters into other binary codes. So going back here to the Braille alphabet, we may see each letter as a 6-bit binary code. For instance, A would be 1 0 0 0 0 0. B would be 1 0 1 0 0 0. So each letter has a 6-bit binary code. So we can represent letters by binary codes with 6 bits, so 6 zeros or ones, and then we may use keep and flip, these 2 elves, to move around these zeros and ones and get other binary codes. So here in this particular exercise, a character called Ari, which was a fairy, was mad at something. So kids found out that she was mad because they applied these transformations. Of course, this is a solved activity, but the point is for them to figure out these mad word. And then we talked about functional composition. So this means applying one transformation after another. Here we are applying a single transformation each time. So you see a single arrow. But then true power comes when we sort of apply one transformation after another. So it's like starting with a few transformations, we can get a lot of effects and actions by combining them together. That's the main idea, but I'm not going into details because that really is not the point. The thing is, functional composition in Portugal is only taught in 10th grade, so when kids are like 15 years old. And because we deal with a functional programming paradigm, we need to teach them this when they're 7. But they understand, so everything's fine. Then when we talk about binary image representation, they use their little boards, 8x8 boards with these black and white pieces, and then we can use flip and keep, the two functions, to transform these images. So here we have the picture of a dog, and then using keep and flip, so we either maintain the color of the little square or flip the color of the square. The kids figure out this other animal, which is a cat. So we also use these matrices that have transformations instead of numbers in order to transform these images. And the point is that this is basically how a computer works. We have zeros and ones, here represented by black and white squares, and they are constantly being transformed into other zeros and ones. So it's just a friendly way of exploring these computing concepts. Then, in the webinar on mobility regarding the second cycle, we started talking about programming concepts because, you know, eventually they should know how to write programs. We talked about lists and functions on lists, which are one of the most important data structures. And basically, yeah, lists all the way through, just different kinds of lists. Lists are also known as arrays in some programming languages. So basically, what's the idea? The idea is that to represent a list on a computer, we must use a specific syntax. So we need to use square brackets, and we also need to use commas to separate the elements. And then we have several functions on the computer that do stuff to our lists. And for us, the functions are like robots, which have a specific task. So here we have a robot called sort, which represents the sort function. And basically, it takes a list, and it sorts its elements in increasing order, you see? So here the numbers are scrambled, and here they are in increasing order. And in the arrow language here, so we start with a list. So this is the type of this object. We apply the function sort, materialized by this robot, and we get another list here. Then we again talk about functional composition. So what happens if I apply one function after another? So here we have a new function called nub, which eliminates duplicates. So here you see 7 appears twice, so these 7 will not appear. And 2 also appears twice, so 2 will not appear. So we will remove duplicates, and we will get this list. And then we are composing it with another function called sum, which is like two robots holding hands, and the output of the first is the input of the second. And sum just performs the sum, so basically adds all numbers in this list, and the result is 17. So in the arrow language, we have a first arrow with function nub that transforms a list of numbers into another list of numbers, as you can see here. So we have a list of numbers here, a list of numbers here, and then we have function sum, which outputs a number. We also talk about a higher order function called map that applies a transformation to all elements in a list. So here, map plus 1 means that we are going to apply transformation or function plus 1 to every number in this list. So 1 plus 1 is 2, 2 plus 1 is 3, 5 plus 1 is 6, and 8 plus 1 is 9. The most important thing for you to realize, even if you don't really care about computer science subjects, is that we always try to teach in a way that students somehow create an emotional connection with what we are teaching, with our contents. And here, this emotional connection is created by using these robots. Okay, because instead of jumping to abstraction very early on, we start with concrete material, and you know, it's a mathematical function, but you may think that it's just a robot that has a name, and this makes kids more willing to learn and not so scared about learning. One of the things that is so frustrating is when kids are afraid of math, for example. Because why are you afraid of acquiring knowledge? It's just awful to think about it. And so we don't want kids to be afraid. We want them to learn freely and to feel in an environment that is comfortable for them to learn and where they feel safe to make mistakes. So we try to just produce contents that are friendly and that seem friendly and not scary, because if we go straight to, you know, mathematical notation very early, they just get scared and they don't want to learn anymore because they are afraid to fail. That's basically what happens. Then we also talked about pairing lists. So, you know, probably all of you or most of you are wearing a zipper in your clothes, like pants or something. So we talked about that operation. And then we all talked about dictionaries on the computer. We talked about graphs and how they model social networks. And like how Google Maps works. And then in the last webinar regarding the third cycle, it was more Python oriented. So we talked about, I mean, not we, but Open University talked about some Python fundamental concepts and how to create Python courses on NetAcad, which is like a platform that allows you to create courses and play around with these programming languages. And now back to Louise, which will very quickly tell you about the results.
Just to summarize, because we are just finishing. So, the most important thing for you to know is that everything that has been shown to you, in terms of programming, the concepts that we are dealing with on these slides represents probably 80 to 90% of the things that we do with any programming language. Okay, because when we are talking about programming language, and we are talking about programming computer, we are talking about mainly two things, okay? Data representation, and then data manipulation, or transformation, or algorithms, okay? And when we are dealing with these concepts by using these robots and these characters that we have been talking about, like keep, flip, and so on, we are in fact teaching our kids how to deal with these concepts. And this competence, again, represents approximately 80 to 90% of the things that we do when we are programming, and when we are programming with any programming language that exists, okay? So, and this is really important. Then that's why we are talking about computing and not programming. We're talking about the concepts that will allow students, and of course, again, in Computer Science for All, to allow the adults that will teach students to deal with these concepts in order to be more effective. In terms of results, and just to summarize, one of the most important things is that all these webinars and blended mobility, so webinars and blended mobilities are related to each other. The blended mobilities are more hands-on activities and hands-on sessions. You can use your smartphone if you want in order to use this QR code to go to the YouTube where all these materials are available, okay?
Yeah, and the QR code goes to our YouTube channel, and in our YouTube channel you can see the videos of the webinars and blended mobilities.
Yes. And so these 4 webinars, okay, first of all a more general overview, then the one with the covering first cycle activities and concepts, then second cycle and third cycle. All of these materials are available at our website at YouTube, and so please feel free to go there and to see what we have done related with this. Okay, so these are the titles of each one. The Innovative Education in Digital Era is precisely the general overview, and we will talk about everything that we try to apply on these three cycles. Then one for the first cycle, then one for the second and the third. When we are talking about mobility, essentially is the same thing, okay, the same concepts, but a more practical and hands-on session, okay? And then we are also producing intellectual outputs that corresponds to study programs, manuals, methodologies in a massive open online course. So everything that are in our webinars and our blended mobilities will be also available as a MOOC, so a massive open online course. All these other materials are being produced by the consortium, and by Collecti ourselves and Open University as well. These will be available soon, okay? So the project just for you to know as well, we'll finish in August 31, so we'll still have approximately 2 months of work, so all these things will be available soon. And then we have these multiplier events, so this will be our last conference. So we have 2 before, and that's it. So we'll be available now for questions at the end of Phil's presentation. So thank you very much for your time. And it's now time to Phil.
Thank
right?
you all.
Thank you.
Test, can you hear me? Yeah. Okay, so I'll just introduce myself. So I'm Phil Hackett. So although I work for the Open University, I'm going to talk about my experience as a teacher in schools when computer science was introduced, replacing IT. Backwards. Yeah, so it's my perspective of what actually happened during that period of time. Okay, so just to give some background into my experience. So I spent about 10 years working as an IT network manager in schools, and then in 2009 I started my training to become an ICT teacher in schools. Then from the period from 2010 onwards until a couple of years ago, so I was an ICT teacher, but because of all the change, I was also considered a computing teacher. I was a CAS, that is Computing at School, master teacher. I led a community of practice, and I was curriculum leader and had various other roles. So, and as I said, as I work full-time for the Open University now, I still go into schools and provide support to pupils and their teachers. Okay, so just to give some background onto what it was like when I started as an ICT teacher, so in the year that I trained. So ICT, and this is different, the different cycles that Ines mentioned, so our ages are different. So our primary school is age 5 to 11, secondary school is 11 to 16, and then we have 16 to 19 is our advanced level, but it's still secondary education. So ICT was compulsory in all schools, so all schools had to teach it, and I'll talk about the secondary, which is the older ones now. So we taught 1 lesson a week, and we call that Key Stage 3. So 1 lesson a week, and in those first 3 years, students were taught, people said it was just office skills, but it wasn't. It was safe use of the internet, it was presentation skills, document skills. They might have done things like mail merging, quite advanced things. They were also taught creative skills, so animation, and so we use Scratch, but we used it as an animation, really, in ICT lessons. And yeah, so lots of different things were taught at those early years. And then at Key Stage 4, again, it was one lesson a week, but every single student in the school studied ICT, and every single student in the school, pretty much, or almost everyone, would have come out with a qualification in ICT. Okay. Those who opted to do more more ICT, they might have 4 lessons a week, and they would have done things like games design, control systems, video editing, sound editing, and as well as all the advanced office type skills, it was a very, very creative subject. Okay, so I really enjoyed teaching it. I think the pupils enjoyed it. There was no gender balanced issue or concern really, because every single pupil did the subject, and even those opting for it, you know, so there wasn't too much of a disparity really between the genders picking the subject. Okay, and then it kind of changed, or started to change. So in May 2010, so there was a general election in the UK, and the Labour government that was in power was replaced by a Conservative and Liberal Democrat coalition government. At the same time, there were lots of voices, different voices that were complaining about ICT in schools. One of the very big respected organisations, the Royal Society, so they, in 2010, they said, oh, ICT lessons are a turn-off in schools. In January 2011, so these voices kept coming, so from Microsoft, then in January 2011, and Microsoft executive said, many teenagers are immersed in technology at home, but are failing to translate this into learning technology skills at school. So Microsoft had some intervention. Google intervened, okay? So in August 2011, the chairman of Google said the country that invented the computer was throwing away the great computing heritage by failing to teach programming in schools. And then goes on to say, your IT curriculum focuses on teaching how to use software, but gives no insight into how it is made. Okay, so, and these voices kept on coming. There was, so Ian Livingston, again, he was a video games, president of a video games company, Eidos. I think they made Tomb Raider and various other games. You know, some very, very big names were complaining about ICT. Then the Royal Society, again, they had been producing, working on a report for a long time. So all through 2011, working on a report. And they published it in January 2012, and the report was called Shut Down or Restart, and really it's adding to all these voices from Microsoft and Google and video games companies and saying there needs to be a change. And then in kind of a surprise announcement, almost at the same time, so it kind of surprised everyone. It surprised the ICT teachers, it surprised the schools, the training providers, head teachers. The government just came out and said ICT will be scrapped, so it will not be compulsory in school, and it will be replaced by computer science. So that really did come out of the blue and was a big surprise for many people. It wasn't too much of a surprise for the organisation Computing at School, because they had been calling for it for a long time. Okay, so they started as 4 individuals in 2008. I think 1 or 2 of them work for Microsoft Research arm, and their mission was to ensure that computer science is considered a proper subject on a par with maths and chemistry, and it should be taught to every single pupil from the age of 5. Okay, and listening to Ines' talk and Lewis, and I think CAS sounds very similar to the CS for All project. It's the same kind of initiative, trying to make sure that computer science is respected as a subject. Okay, so what followed really these announcements in 2012 was a few years of uncertainty, because ICT was on the way out and computing was on the way in. So just to give some perspective, so in 2010 there was only one exam board that actually offered a qualification in computer science, in computing in the UK, but in February 2012, so 1 month after the announcements, all the other exam boards said that they would produce a GCSE computing exam. Trainee teachers, they were no longer, so I trained to be an ICT teacher. The teacher training had to change overnight. So you were now trained to become a computing teacher, not an ICT teacher. Okay, so, and to be honest, there didn't exist any official computing teachers. And, you know, so it did really need to change, or change quite quickly. So this is where CAS come in and made a significant difference. So in partnership with BCS, CAS formed networks and communities which allowed teachers to share ideas and to teach other teachers. Okay, so in sharing ideas and best practice. And I think it had gained some funding, so it only got, say, £3 million of funding, and it involved some universities to kind of form these networks and provide a little bit of time for them to train other teachers. The original plan was to train 400 master teachers, and then they would go on and train other teachers. Okay, so the big problem that really existed was there was a shortage of qualified computing teachers, and only 35% of those I think in 2010 had an actual IT or computing qualification. Okay, so over and then the solution was these master teachers. So over the next few years, there were loads of exciting developments really that happened. From lots of different companies. So I'll just put some of these on here. So the BBC, they gave 1 million of these microbit devices. So basically it was aimed at every single 12-year-old in the country. So they all got one of these, and that let them program. They could use a mobile phone and or a browser or a computer and send a program to a little device that had LEDs on and sensors. So that was one of the initiatives. Raspberry Pi brought out a very, very cheap computer, maybe £30, and it was a full computer that could be programmed. Loads of it. I'm kind of short of time, so we'll just kind of skip some of these really. But all of these initiatives helped contribute to the excitement and enrichment of computer science as a subject. Okay, so just talk about some of the challenges. So some of the early concerns that computing might put off girls started to become evident with the gender balance. So really, in 2014, again, these are just headlines from that show the progression. There was concerns initially that girls might not pick the subject, and then by 2016, it became evident that was actually happening. And then in 2017, there was alarm bells over the classes, and you can see the progression over time, and digital skills gap, and we can see a couple more, hopefully. Yeah, computing in steep decline. Now these headlines don't tell the full story, because by ICT stopping, the numbers, obviously, every single pupil did ICT, and then they've gone from not every pupil doing computing. So that's why it appeared to be a massive steep decline. But because we were not teaching ICT skills to everyone, that's why we have a digital skills shortage crisis on possibly at the moment. Again, slightly shorter time. So again, the government realised this, and in 2017, they thought, well, 400 teachers is not enough. The Royal Society recommended 8,000 teachers, and they wanted 60 million, recommended 60 million of investment. Again, the government decided to fund it to £100 million. So the government put in a massive amount of money. The National Centre for Computing Education was formed, and that was a partnership between CAS, BCS, STEM Learning, Raspberry Pi contributed with research and resources. But it took 5 years before really the country was in a place where enough teachers were being taught, where the resources were in place, and there was enough funding for this to all happen. Okay, so where are we? What does the future look like? Okay, so we do have higher student numbers now. So I mean, but we're 10 years on, over 10 years on. We do have better qualified computing teachers, and a lot more of them. Computer science is respected as a subject, but there is still a shortage of teachers. Now, so just to kind of point to this, so the number of entries for computing jumped by 10% this year, and it's the first time that there are more computer science students than there are PE students for the first time in this 10 or 11 year period. And then just to mention about this last article, again from a few months ago, so there is a global shortage of computer science teachers. So again, initiatives that that you've heard about today, it is very, very important that these are successful. And so I would say any plans to introduce computer science, it needs significant investment in teacher training. It needs to build these communities of practice and links between different organisations. The one that enriched it, like BBC, Raspberry Pi, Hour of Code, all those things enrich the computer science curriculum. Okay, and yeah, there needs to be computer science champions. There needs to be, at every level, people need to be engaged with it. So in the classroom, school management, local and national government should also be engaging with supporting the introduction of computer science. Okay, thank you. So that's my talk, and then I think there's questions for all three presentations. Thank you.
Ara és el vostre torn.
Excellent. So time for Q&A. Questions, concerns.
Que compartim de Computer Science for All.
So yeah, time for Q&A. There we go. So hello and good morning. Thanks for your presentations. My first question for Inés and Luis would be, well, he mentioned that the computing science subject is compulsory in the UK. I would like to know if it's the same in Portugal. You refer to Porto. I would like to know if your initiative is implemented only in Porto or in Portugal as a whole. And I would like to know, what are you doing in terms of gender balance? Are you trying to attract girls into IT? And for you, Phil, I have one question for you, Phil. You spoke about 400 teachers and then the target of 8,000 teachers. Was there any resistance? I mean, did you experience any resistance by teachers in transiting towards this new model? The oldest teachers, so to speak, were they reluctant to evolve towards the new approach that you underlined? Thank you.
In terms of mandatory, in terms of having computing in the mandatory school in Portugal, not yet. we are working for that. So, in order for you to understand exactly what we are doing in Portugal and when we compare that to the UK experience, for instance, okay, so we in SICO, so the non-profit association that we are leading with, so we are creating the program, and we are creating this program in a period of 5 years, and during those 5 years we are leading a big pilot project. So in the first year we have started with 3 schools and approximately 200 students. Then the second year, approximately 1,000 students and 7 schools. And on this third year that ended in June, we are talking about more than 2,000 students and 20 schools. Not only in Oporto, but we are working with schools around the country, because we want to see how the different students and teachers deal with these subjects, okay? At the same time, we are working with our government and with our ministries and so on, and lots of agents, like local municipalities and so on, in order to engage all these people to this main goal, okay? So our main goal is precisely the one that was realized in UK in 2013-14, I think, right? When we had computing as a discipline in the mandatory school, I believe, okay? Okay, so we are working hard in terms of having in 2025 everything tested in terms of this big pilot, which is divided in 2 parts. First, we have tried to test our contents, our program with students and also with teachers that we have worked on. But now we are completely focused precisely on teaching teachers to teach computing at schools, okay? And if everything goes well, until 2025, we'll have all these big model tested in terms of having a political decision like the one we have seen in UK, okay? In terms of gender, that's precisely the same thing. So the way we are teaching these things, the enthusiasm is, I think, the same when we are talking about boys and girls, exactly the same, okay? And that's the good thing. And that's what does not happen when we, for instance, start directly with programming and or with robotics, okay? Because when we are talking about the hardware part, the engine, the computing stuff, okay, in the beginning, that is more a thing like attracts boys more than girls. But when we are talking about the concepts first and then the rest, okay, don't forget that in terms of the history of computing, the hardware parts have become more related to the human, to men, and the software part to women. Just because women were more related with math, so the computers was an expression that was used to women that were good in math, okay? And so that's why when I'm talking about gender equality, in fact, the history of computing shows us that this is, in fact, one of the achievements that we have been working on, and by putting women and men working together. Okay, and so that's our experience. I don't know, Inês, if you want to
No,
add
already
something.
said everything.
Yeah, with the, okay, so the resistance, so initially, so in training 400 teachers, so I think there were a lot of very enthusiastic teachers. So I had a degree in computer science, and you know, so I was someone who could train the other teachers, but lots and lots of teachers either left, because I mean, effectively they were being told, you were not going to teach ICT, you were going to teach computer science, and they are different subjects, you know, so they require different skills. They, you know, so someone who was teaching ICT wouldn't necessarily know how to program in our language, but then all of a sudden they got told in January and they should be doing it from September, you know, and you know, so there just wasn't enough time. So lots of people left. There was a lot of resistance, but by the time we got the 8,000 that investment, there were already lots of trained new computing teachers who were replacing the older ones who were leaving. So initially, lots of resistance, but it's because it was an instant switch instead of perhaps a phased approach. If it had been phased, and if ICT had been kept, that would have been much better. Okay.
Thank you. I would like to ask Phil, our colleague from the UK. So in the last few weeks, we've heard quite a lot about to what extent technology is dangerous for education in Sweden, in the Netherlands, etc. So in the UK, you have been fighting for many years for digital alphabetization, and I would like to know if you consider that digital alphabetization goes against, let's say, analogic literacy, So do you believe that digital literacy undermines real life or analogic literacy? What is your experience? And is there a trade-off between the two forms of literacy? Let me anticipate that my answer is that I believe the answer is no, but I would like to know what is your take on this. Thank you.
Okay, so digital literacy, yeah. So I mean, yeah, certainly in the past few months, there's been a lot of concern about the AI, artificial intelligence, and how to use it. So there's been big concerns with that. I mean, digital literacy, yeah. So that's a key skill, and I think this is the reason for the digital skills shortage, or the headlines about digital skills shortage, is because the digital literacy that was taught perhaps in the ICT curriculum, which was kind of scrapped, and there was too much emphasis on programming. But computer science isn't just programming. There is a lots and lots to computer science. But yeah, I mean, I think yeah, I mean, it needs to be taught from age 5 all the way through schools, the digital literacy side of things, as well as the programming, as well as the all the other things that you need to know about about computer science. Okay, so I'm not sure if I've answered your question correctly there or not, but.
Sí. No, per ser potser més específic.
Let me be perhaps a little bit more specific. Let me reframe the question. Do you believe that the more children learn to program, to use more and more screens, do you believe the more digitally literate they are going to be less interested in reading books, in, going for a walk down the road? Is there a trade-off between digital literacy and analogic literacy and the development of other skills?
Yeah, okay. Yeah, so, I mean, I remember teaching pupils, and one of the things I say is just switch it off. You need to disconnect. It's very, very important to disconnect. And yeah, I can see it too much access to screens is a negative thing. So I think it's important to switch off, turn notifications off. You don't need to know when you get an email or a message or a ping, that's, yeah, so, and certainly youngsters, so they should be, it's not restricting it, but taught how to use it wisely, and in a measured approach, but obviously that takes the parent, it takes the teachers, and ownership from the children as well. I think that's a very important point that you've raised.
Hello, and good morning. I've got one question, and perhaps it's like too bold. I've been an IT teacher for quite a long time, and at the beginning we would teach the students about the structure of a computer, RAM memory, ROM memory, etc., because I thought it was very important. It was key to understand how a computer works for students to understand what's happening inside computers, whereas today it makes no sense to teach such skills. Now we are teaching programming to our pupils, but more and more I hear about programming without programming, or programming languages that use natural language, the AI, which allows you to code with a prompt. And perhaps we are faced to a new scenario. Are we really gonna need to program in the future, or is it better to have a good idea and ask an AI tool to develop it? So how does the project match with this new scenario that will be so much marked by artificial intelligence?
Well, all those things are still important. Okay, so I don't know if you want to start first.
I mean, well, it sounds like, you know, you were already teaching aspects of computing in ICT curriculum, you know, which is good. But I think there has to, who will write the AI software? Who will understand it? The AI software, you know. So it needs the computer science. People need to be. And plus, it's not just programming. So computing is much more than just programming. So absolutely, you still need to learn it. You need to understand what's going on in the background with AI, as you know. So and you need to, obviously, if we're teaching AI as well, you need to understand how to prompt the AI correctly. You know, so that's also a skill that we've not really thought about. Again, it's a new scenario, prompting or communicating with an AI to ask the right kind of question.
But what I was saying related to your question is that at those times, and I think that those things are still important. The only thing is that that was a starting point on a specific period. And why? Because we were talking about autodidactism. I don't know if it's that word. So we bought a computer, so we are talking about the 80s, so the first personal computer. And then, of course, it was imperative to start with the architecture and then with the imperative paradigms. So in terms of what is a computer program, is a sequence of instructions that computers deal with, okay? That is still important, but on those times, when we are starting all those movements, were when we were approximately 14 years old, 15 years old, okay, 12 years old, things like that, okay? So that we were computer enthusiasts in somehow, and we are dealing with a machine, and then how to do things with machines, how to do a program that could create a video game or something like that, okay? But now we are talking about putting this in starting at 5, 6 years old. And so in order to be there, so then we are talking again about the 12, 13, 14 years old, in order to be there, what should we now teach to these students? And in our view, we should start like Inés has showed you, okay, with characters and so on, with stories, with fairy tales, things like that. In terms of, because we are now, first of all, we start to deal with concepts, important concepts. Nowadays, we know that are the most important things when we are talking about computer science and computing in general, and then programming, okay? And so, for me, the things are related because I put exactly those kind of knowledge and the learnings almost in the same time, when we have 12 years old. But before that, we should teach computing, and when we have 12 years old, we have 6 years, 8 years of computing behind us. So that's how I see things now, so more, let's say.
Yeah, and regarding the artificial intelligence part, I do believe that in some years, instead of 100 programmers, we will need 10. But we still need the people to understand how AI works, as Phil said, and AI doesn't always provide the correct answer. So we need to have some criticism, like, is this right, is this wrong? So I think that the knowledge, computing knowledge, will always be necessary, and even more necessary when we are dealing with more complex and sophisticated fields like artificial intelligence. We cannot think that we know without really knowing.
Yeah, for instance, in our view, the way we should deal with artificial intelligence is precisely to have computing in the mandatory school. Because that's, for us, is clear, okay? And another thing is that nowadays, lots of people are putting lots of expectations in artificial intelligence, lots of them. I'm also a specialist in artificial intelligence, and I must say to you that, look, that is only a different kind of algorithm. That's it, okay? So the other thing is that we are now dealing with huge amounts of data because of internet and so on, and computer power is also even more powerful than before. That's the difference, because when we are really talking about how the way these things work, that's no magic, okay? That's computer science as well. So they were talking about data flows and so on. And so as people will realize, I think very soon, all the expectations that we have, because at this moment, people are, well, look, this is like magic, okay? So I'm talking with a machine and so on. But in terms of true answers to our problems, it's like this. So everything that is in production in somehow, then yes, that will be replaced by computers. Programming, writing reports, things like that, everything will be replaced by computer. But everything else, and that's why we need, again, to be focused on the human factor. What are we in terms of human beings? And we are creative, we are imaginative, we have dreams, and so on. And so we need to put this into our activities. Otherwise, of course, all the rest will be replaced by machines, that's for sure. And so we need this knowledge, this in mandatory school, in order to be able to understand not what artificial intelligence do, but what are the ingredients that are making this possible. What are these ingredients? And how I should change this in order to be effective in terms of artificial intelligence. Now I should use them. Sorry, Martin. Because these are very interesting subjects.
You wanted to answer?
I've answered?
You already answered.
Yeah. I've answered already.
I saw you with the microphone. Doncs, moltes gràcies.
Thank you very much indeed. If there are no further questions right now, thank you for your presentations. Thank you. Thank you for sharing your experience, and thank you for your wonderful project. It is a real challenge, and it's a great luxury to have you here with us. Now we will have a short coffee break, and you will have some food and coffee outdoors. And there's a group of young people who have come from Collectic to prepare a workshop with disconnected games. So enjoy and have a good break. So we shall resume at past, okay? Resume at past. Be useful for people, for communities, for society at large. And it should be useful so that we all have a better life. And in order to attain this, we need to work for some deep social transformations that oftentimes start at school and the educational community. In this second block, we are very happy to greet and welcome 5 people who are significant and key representatives from the educational world in Catalonia. So, we welcome 4 short presentations, one after the other. 8 minutes per presentation, and then we will have some time for Q&A between the speakers and the audience. So let me make a short presentation of the 5 people who will be making the 4 presentations, and then I will give them the floor. We have Jordi Sarró, who is the Deputy General Director of Research and Digital Culture. He is a Deputy Director General of Digital Culture in the Ministry of Education. And then we have Monica Febo, who is a technician in the Digital Inclusion Service of the Directorate General of the Ministry of Work. Then we have Xavi Rossell from the Milà and Fontanals High School in Barcelona. And the 4th presentation will be made by Maria Berrocal and Edouard Montaner from the University of Girona. So, Jordi has the floor. Thank you. Thank you all. As mentioned by Martina, I've come here to present the different initiative actions carried out by the Regional Ministry of Education. I have very short slides, and I'm going to try and use the time that has been allotted to me. At the Regional Ministry of Education, anything related to computational thought has been structured into 4 main programs, which are the ones you can see here. The so-called Unplugged PC, Scratch and Scratch Junior, the Inventor app, and Microbit. We collect all of this on a website. You know that websites promoted by the Ministry of Education are NOVAs, a specific computational thinking NOVA. Now, these main goals that we want to achieve with regards to computational thinking, which are channeled through these 4 programs, are the ones what we see underneath. We try to collect, on the one hand, the whole deployment of computational thinking into classroom activities, focusing above all on the student. But we try to do all of this on a collaboration base. And we look for the support of teachers in 2 ways: by collecting pedagogical actions and proposals carried out by the schools, and on our website you will have learning activities related to these 4 main strategic lines. We network to share information amongst the teachers, and we provide training so that they can make headway from the point of view of the professional development of teachers in terms of computational thinking. Having said that, what has happened? What have we found? We have found many things. We're acting a little bit, well, looking backwards, and I shall mention something that may not be included here, but is a challenge for the future. What have we found? Issues related to teacher training. We have a very diverse teacher's body. Things that are part of my competency: digital, computational, or computational thinking. I mean, there are teachers that have never ever had any type of contact with computational thinking, and others are experts. So it's hard to define the sort of training that teachers need. And this collaboration network has been useful through the news network, which we use for many collaboration actions. collaboration-based actions. And within this news network, we have a specific network for computational thinking. We're looking for all of the synergies with the classroom. And therefore, this is what I've mentioned beforehand. We want to make it easy for teachers to find experiences that are being carried out in other schools on a daily basis. And based on this, well, we're quite happy, actually, about how things have gone, because we have been working on these initiatives for a number of years, all of them based on computational thinking. And for example, in the first program, the Unplugged PC, we have 43 centers that participate. With Scratch, we have 679, and with the app education, 510 schools. So these are figures that we believe are quite significant. In terms of teachers, we have a high number of teachers who have been trained for all of these programs. This is one of the lines we're trying to promote with regards to digital training skills. And these are the number of people who have trained following these strategic lines, and also dissemination lines. The 2023 15th conference with 336 teachers and 10 workshops, the Code Week, or Student Awards, which I'm sure you have all heard about the End Schools program. So what are the lessons we have learned? It is increasingly difficult to increase these figures, this number of schools, and the number of teachers who are involved in computational thinking. It is increasingly difficult, but we will do it, because we have a big challenge for next week and the following year. We should have a significant deployment of robotic elements in all schools. And therefore, we believe it's going to be the democratization of these elements so that they reach all schools. And this is an enormous challenge, not only, I mean, from the point of view of what we have done so far, but for the future as well. And this will allow us to expand this basis of teachers who will include computational thinking in their teaching proposals and all of the training associated for them to actually make progress. What else? We have learned, number 4, the enormous creative capability that students have when it comes to facing challenges, analyze them, and find a solution. All of the classroom activities, some of them are simple, others are more complex. Learning situations, they're all based on the computational thinking we want to include, not to link it up with a syllabus, a technology syllabus, which is what we have to overcome. And that's why at the beginning I showed the vision, this sort of like overview, how to face daily life challenges in order to link up with the students, with real problems, with daily problems that promote engagement and motivation to solve problems and to find finally a solution. We believe that in addition to the framework that the current syllabus gives us, I mean, most curricula include computational thinking and robotics in the different curriculum areas, both in the first and second training cycles. It allows us to make headway in the concept of integrated work to overcome what has been said before. I mean, we're living at a time in which the point is not to produce programming technicians who know about the different components of a PC, which is how computer science classrooms started, to actually make headway in the use of technology and computational thinking with regards to the use of problem solving in our daily lives, and to include all of these interdisciplinary learning lessons in problem solving. Well, I don't know how I'm doing time-wise, but basically this is what I wanted to share with you. This is an overview from the point of view of the public administration. We're trying to channel it through these 4 channels I've mentioned. So now I'm going to give the floor to Monica. Thank you. Well, good morning. Let me start out by saying that at the Secretary of Digital Policies, we had a crisis. At the time, we started thinking about this presentation. Initially, people were not counting on women for a first definition, and the colleague who had to make the presentation, when we were told, he said, we have to be a model, we have to be a behavioral model. I mean, if we are promoting the involvement of women, well, a woman should be making this presentation. So, together with the team, we have decided to develop jointly the Secretariat's policies. And this is the reason why. Okay, what do we do? At the public administration, you may wonder, what do the digital policies department does here? We have no competencies, but in our Directorate General, we have the competencies for the citizens' digital skills building in general. So here, well, this is where my presentation will be actually, will be placed. We are from the Labor and Company Department, and we have worked in a well-coordinated manner with the Regional Ministry of Education in many projects. So what are the key questions that we want to answer? The Plan CAT as a starting point was developed in 2017 and 2019. The pandemic actually affected us very much, like so many other projects, and that has implied we have had a difficult life. What we have developed, what we had planned originally, has not been developed fully. The first goal was to actually develop the digital competencies of citizens during their first education phases: science, engineering, and mathematics. We want to promote interest for technology and promote digital vogue calls. We want to have, we want to act on the enormous gender bias that we have in these fields. So what are the challenges? What are the challenges we worked out? What are the challenges that we have defined in terms of how we work out computational thinking and programming, computational programming? If we are addressing ourselves to citizens at large and their digital skills, the main focus are citizens, but not only, in the formal setting, but also in an informal setting and in an extracurricular setting. And that's why from the beginning we wanted to know what is the technological leisure time landscape like. And here we carried out a number of actions. For example, the Bitboard project, in which we saw this structure in our territory in terms of extracurricular leisure time computational activities. Okay, the pandemic had an impact on this field, and as a result, by 2019, I mean, we couldn't actually achieve our goal. We were worried about the computational skills of people, as Jordi has said. We have also been part of the definition of these skills that teachers must have to teach computational thinking. In terms of promoting our offer throughout Catalonia, it is, the supply or the offer is not the same everywhere. And here we have actually seen an inequality problem throughout our geography. And finally, the reason why I am stressing this out is that how do we make these technological extracurricular activities be attractive for girls? Okay, let me now focus on the experiences, which is how have we reinforced this SEMCAT plan? SEMCAT was from 2019, as I've said, September 2019. Well, in June 2020, we approved the Donatic plan. With the Donatic plan, this is what the SEMCAT plan pointed out. I mean, women are not interested, girls are not interested in science and technology. So we take it up again in the Donatic plan. And what we do is to promote the fact that there are more role models to make visible and to recognize what's the role played by women in the field, in the technological field. And here, for example, I could share with you the case of a recent campaign about women and technology, where we have used 12 key women in different fields so that they act as role models and so that they give visibility and they can be role models for young girls and for students at large. And this was done in one school with students from the 1st to the 4th year of high school. And the women who are part of the campaign could have a dialogue with the students, both girls and boys. Other actions we have carried out in the field of gender bias to promote women, and I shall talk about this later because the next roundtable discussion, the next panel discussion will talk about this as well. We have also participated in it. Or in international congresses like the day devoted to girls and science or the day devoted to girls in ASTIC. Here we have given space to other networks with the Association of Women for STEM, or WIA, which is the aerospatial field. And here we've organized with a primary school so that there are women and role models, so that they get to know them. If you do not know it, you cannot love it, you cannot learn it. That's a motto. So this gender bias, this lack of role models, should have the possibility of being visible and the possibility of being recognized, so that women, girls feel actually identified with it. So we actually promote technology from this point of view. What are the outcomes? What are the outcomes? Here, I'd like to highlight that this is the result of a cooperation between different agents in the field of science. With technology, we can go further, and together with a public-private partnership, we can go beyond, because that allows us to be where the administration is not present. And we can do it all together. And here we have experiences like the Bounty network, where in the field of leisure or the non-formal field, we are also doing some programming that's quite significant. These are agents we have out in the territory. The STEMCAT plan, unfortunately, due to the pandemic, the STEMCAT plan has not been able to, well, we have not been able to assess it. And what are the lessons learned? The impact is achieved when the proposals are promoted by the school. When the figures mentioned by Jordi, I mean, we want them to be more numerous. We want to have more people. We want to have a better coordinated action involving teachers, schools. We need to have a public-private alliance that allows us to work in a systemic way. No matter how much the different regional ministries work on robotics or an international Women and Sciences Day, that will be useless if we do not actually do it with teamwork between the different public administrations involved in this field. Now, with regards to technological leisure time, this is a space that should have greater resources, well, I've told you about the pandemic and how it has affected this field. I mean, it has actually disappeared in many places. So how do we restart it? Wherever we do not have technological leisure time, we should have that space and we should have that resource through a grant system, maybe that would be highly necessary, especially in places where they do not have an extracurricular technological offer. So, what has happened? So it is a very good level. It is a wonderful opportunity to be able to work in this. We have the Omnia and Punti networks, where we believe we can have a good effect. And ultimately, the gender issue. If we want girls and women to be interested, if we want this to be attractive for girls and women, we should not approach it from the point of view of the ultimate end. I mean, we should not approach technology as an end in itself, because that doesn't make women and girls to participate and to be interested. But we should be able to talk more about what's the end use of it. When we have applied a digital solution to a problem, for example, the M Schools project that works like that, or the Technovation program, we have actually had parity, gender parity. We have had 50% of women and a wider sector interested in ICT. So that's why we want to have better indexes in terms of the participation of women and students in general to devote themselves to these technological solutions. If later you're interested, I could give you greater information during the Q&A session.
So I'd like to share a few experiences from a public network of high schools here in Barcelona regarding learning scenarios. I would like to elaborate on what you said before. We have been working in cooperation with other entities, with neighbor-based organizations, other partners, and I believe, well, the team to which I belong believe that there are interesting things that can be replicated, interesting practices that could be replicated in other environments. I would like to speak about Fina. Fina is an old lady who attends who lives in an elderly home, and we meet her every week because she is part of a community garden that we visit on a weekly basis. So once Fina was upset and she came to me and she said, you know, 2 of your students laugh at me. So I asked them, what's wrong? What's the problem with her? Are you really bothering her? And they're like, oh, the thing is that she repeats one same pattern. And I was like, what do you mean by that? So she was planting tomato plants, and she would do it exactly in a very well-structured manner. And these students had undergone a computational thinking seminar, and they were making fun about to what extent she would repeat the same process once and again. So I went back to her and I told her, no, it's a matter that they have learned things and they can see you, an adult person, repeating one same pattern. But it's not like they are laughing at you, but considering that your pattern is interesting. The way you plant your tomato plants is interesting. So this is a proof of what I meant before. We participate in community projects that contribute to working for communities, and we base our actions on computational thinking, be it patterns recognition, abstraction, or the use of algorithms to carry out repetitive tasks. I would like to share a few images with you and I want to save as much time as possible for the Q&A session. So here you can see our pupils who are building furniture which are to be installed in a little square called Els Àngels by the Museum of Contemporary Art here in Barcelona. So they self-organize themselves. It's quite interesting. It's quite interesting to see that when you split the task, it's very interesting to allow them to self-organize themselves. They do group tasks, and they do so with the participation of an architect office from Seville. On July the 1st, we started installing all the pieces of furniture to this little square. We want to bring the classroom to the street. We want to combine theory and practice with real-life activities, because we consider that pupils become much more responsible and aware when we bring the room outside to the streets, because they are committed with others, with their peers. Of course, we do not work alone. We are working in partnership with many different stakeholders. We count on the support and funding of universities, networks, etc. So we've done a previous learning, which is today useful to have more ambitious targets. Let me quickly go through two work lines. One, intervening in the public space. Today it's very a la mode. There are some architecture studies that operate in the public space to rethink public space. So this is a way of doing politics from the classroom, because at the end of the day, it's children who contribute to rethinking and reshaping public space. All these proposals, for example, are based on developing furniture or toys or physical items that are installed in the public space. So they become a network of resources, of public resources. So yet another way to doing politics. Then we have another work line, which is networking with primary schools, visiting primary schools, seeing how children play there and rethink what toys they could have that they don't have. So we design them and manufacture them and offer them for free to primary education students. So when we play with a tool or a toy that we have designed ourselves, this is a way of implementing computational thinking, making things operational. So these are our main 4 work axes: context, a relevant context, meaningful context, a meaningful learning process, and of course, social skills. It is important to enhancing social skills amongst our students. This is working very well, and we'll keep going down this line because it's really boosting up engagement. Look at them. They are very engaged. Here they were building an insect hotel for the elderly home center. So they developed this little hotel for insects and offered them to the elderly. Look at Marcus. He is terrible. And look at him. He's so thrilled, so happy, doing things for others. Only for this it's worth it. So as I said at the beginning, it's about being in the streets, acting in the public space, contributing to reshaping the public space. There is another project in MACBA, in the Museum of Contemporary Art, which is developing a circulating garden, a portable garden, so that citizens can benefit from it, rethinking the space, rethinking in partnership with other relevant stakeholders. Again, allowing children to play, to try new things, to participate, and to operate in the framework of computational thinking. Here are some Instagram pictures of our students playing out in the streets so that Raval neighbors can use their creations. Yet another image of the portable garden project. Look at this image here. There is this pilot that ended up being built into a wood bench. Let me assure you that this was the case. I was there, I've seen it, it's quite amazing. Wood, trees, to have some shadow in the square, it's really, really nice. Or these toys, which are crafted for responding to the specific needs of children visited in primary schools. Yet our students at work, it's quite incredible how they gain ownership on the project when they engage directly with architects or designers. You know, teachers step out or step back and let them lead the process. The majority of these children are super disruptive in class or at class, whereas they behave super well when they're out in the street. It's quite incredible how things change when you move to another place, right? So these community projects that allow us to get out from our walls contribute to well-being at school also. So I only wanted to give you a hint, and I encourage you to embrace community-led projects because they are amazing and the outcomes are really good. Hello and good morning, one and all. We are Maria and Eduard. We are from UDG, the University of Girona. We both work in a research group called Digital Edu, Digital Education, in which we explore how technology can rethink the way we teach and learn. And today we would like to share one of our EU projects called Montec. Montec is about teaching, it's an Erasmus Plus project, which is about teaching and learning creative technologies with a Montessori approach, on the grounds of a Montessori approach. So we take Montessori principles and redesign them in order to promote the teaching and learning of digital technology. So in a nutshell, this is the consortium. UDG, University of Girona, is the project coordinator. In Girona, there is a Montessori Palau school. Then we have Italian partners who, in partnership with us, are the technology experts. We have Montessori experts and a long list of organizations from different parts of the world, Greece, Bulgaria, Romania, etc. So what is the project about? The project stems from a question mark, which is, if Maria Montessori were alive today, how could she incorporate technology in the classroom while staying true to her educational approach? Would she use such tools and technologies or not? We wanted to respond to the question from a practical perspective by testing the approach in the school. And basically, we have been training teachers so that they can develop activities based on the Montessori reshaped methodology. Montessori, when she was born, Maria Montessori worked with slum children in Rome, with the poorest of the poor from Rome, and we wanted to go back to this pedagogy because today Montessori pedagogy is used in quite well-off schools. So we wanted to go back to the origins. We want to put the focus in high complexity schools with a high percentage of migrant students, and in other cases like Greece, in schools with a high percentage of refugees. In the case of Bulgaria and Romania, we work in schools with a high percentage of minorities, of Roma minorities. So we work with the vulnerable. And side by side, from Maria Montessori, we have Maria Antonia Canals. Probably you've heard of her. She's a teacher of teachers. She spent all her life designing materials to ensure that learning and teaching, math learning and teaching, was much more practical. So as Maria Antonia Canals did with math, we want to replicate it in the field of technology. We want to make the teaching and learning of technologies much more practical. Here is the timeline. We have a 3 years long project with a quite long list of partners. Year one was focused in the listening stage, listening to the schools and countries to get to know a little bit better about their knowledge of Montessori, their awareness of Montessori. We also drafted a first draft guide with several practical activities. Maria will tell you more about them. In stage number 2, we did the training of trainers. So teachers from different parts of the world came to Girona, and we had a face-to-face training session. We also allowed them to test the methodology for a few months and give us feedback, and we then improved the guideline. The guide has now been published in different languages in our website. We have been doing training of trainers, yet many things to work on, implementation in multicultural schools, and cross-cutting elements which are throughout the project. Here is our website, montessoritech.eu. Oh. If you want to download the guide, it's available through this QR code. Here you can see a picture of the guide. There's an introduction to the methodology and the 3 chapters. Chapter 1 is the great story of technology. In the first presentation, there has been a remark to the importance of the history of technology. In the Montessori methodology, tales are important, and in all tales, there's a story. Then chapter 2, fundamentals of creative computing. We've called it creative computing or computing thinking. And chapter number 3 focuses on incorporating technology across the curriculum throughout the different disciplines. It's a very practice-oriented guide that places the teacher at the center. So within the guide, each activity has different sections. We play with colors, like Montessori did, and in these subsections, we can see the different stages of the creative thinking spiral. I am sure you are aware with them, right? The Scratch team invented them, imagining, playing, sharing, reflecting, etc. So each activity has this, well, we have the different activities. Some are unplugged, 100% unplugged. We've tried and promote low-cost materials. Montessori materials are super expensive, so we have rethought the materials. Some are connected, like Makey Makey, but again, we're working with paper and very inexpensive materials, and Maria will tell you a little bit more. So again, according to the spiral of creative thinking, we focus. I skipped one slide. Oh my gosh. Yeah, so the methodology, the Montessori methodology, focuses on imagination. Imagination is the somehow match that will light up the gas, right? So we do it with stories, anecdotes, projects, or physical materials, or projects that are being implemented by the neighborhood organization, or many other possibilities. Afterwards, we put forward different activities like a Montessori teacher would do. The teacher does a tiny demonstration with a tiny group on an activity. The activity is then left in the room, and then students can freely participate to the activity once it has been already presented or introduced. So boys and girls, individually or in groups, can choose from one activity of their priority in the framework of the context that is being worked upon on that specific day. So many students are not with the teacher, do not necessarily spend all day long with the teacher, and they have to collaborate and cooperate with their peers, and this is why feedback amongst peers is very important. In this Montessori methodology before, we underlined the importance of individual reflection. In this chilled environment, it is important to find a moment to sit down and reflect. So we recover the use of paper and pen, and we ask teachers to, no, not teachers, students to keep a diary where they write down the main learnings of the day, and this helps as a way to document the process. We've already referred to the importance of feedback. Feedback is incredibly important. It has to contribute to helping also peers, and it has to be respectful, positive feedback. We believe that Scratch and Montessori are very respectful of children's diversity, and this is why it is very important to introduce activities with different approaches, because we all have different ways of learning. Here's an example of an activity inspired in the Tinkering Studio, also inspired in Lego Study, MIT, Scratch, etc. An important element is multiculturality. We promote, or we include different cultures, the different cultures of our students, because we are implementing the project in high complexity centers, be it through dance. See, here is an example in which we develop concepts like loops or variables used through these little monsters, which can be unplugged or plugged. So the summary or the main conclusion of our applied research is that we absolutely believe that Montessori would be a scratcher. She would be using creative technologies. We are absolutely sure about it, because depending on the approach you take on creative technologies, you will promote Montessori's principles, which are mainly the respect for the rights of the child, their interests, and their degree of knowledge and awareness, and of course, it is a method. It's a very flexible methodology. It awakens intrinsic motivation, which is what makes us wake up every morning and feel happy. It is a well-designed and prepared interface where everything is at the disposal of the children in a very ordered manner. There is a self-education element where children, learn and fail, and we don't have to tell them they have failed. The program tells the student that they have failed, so you get to know you've failed immediately, and this promotes independence, freedom in a well-structured environment, so freedom within limits, which contribute to holistic education. Thank you very much. We're going to leave it here.
Moltes gràcies a tots vosaltres.
Thank you very much to all of you. Thanks for your presentations, which have been very thought-provoking. My apologies for pushing you, for rushing you. We have very little time available, but we would like to know what is your feedback? What do you want to tell others? What reflections and thoughts you want to share? And of course, we'll also open the floor for the public. I believe that something they said is very important when it comes to motivating students, and you also underline the importance of positive feedback, creative feedback, and finding ways to give feedback. Our experience is that when feedback is given by teachers, it has a certain value, but when feedback comes from the outside, you can really find like a gold mine. Feedback becomes a gold mine, and in community-based projects, you don't really know why, but feedback gains a lot of importance, especially when it's given by a third party from outside the school environment. So we are working on systematizing feedback, because we believe feedback is a change lever that can boost up pupils' motivation. So if you have any best practice or good idea, please do not hesitate to share them with us. And it's not easy to give positive feedback. We need to work on positive creative feedback. So I wanted to ask you if you have any best practice. And even more so in the case of girls, it's fundamental in order to boost the self-esteem. So there is a lack of role models in girls, and it's very important also to somehow urge girls to give feedback when they feel questioned, right? Or when they have to work twice as hard as boys to prove they are well prepared. And yeah, it's absolutely very important. Your experience is very important. your experience with girls, and also on how we can help boys be more careful and more caring. We need to make sure that boys also are caring amongst them and perhaps a little bit more benevolent, and perhaps ask them to use technology to promote this field, which is caring about others. So we need to empower girls, indeed, but also boys. We need to empower boys, be more sensitive and respectful of the group. Thank you. I would like to underline the following. Of course, we all work in different environments. I work in a public administration. You work in the first line, in the classroom. You are in the academia. You are in another public administration. Nonetheless, there are common grounds. There are, common grounds. The bottom line is there, right? And I believe that what's really remarkable is that we need to go one step beyond the use of technology per se. Of course, we need to go down the line of technology invisibility to put them at the service of an ultimate goal, which is learning. Learning technology has to become invisible, and it has to become a tool for a greater purpose, which is overcoming gender gaps, overcoming barriers and challenges, promoting learning, and I believe this is a proof of to what extent things are moving on and forward. And it's very important to have the opportunity to talk about it, because indeed, sometimes from public administrations we have a certain limitation when it comes to meeting and telling what is it we are doing, and we need to also engage in an active listening process to listen about other projects which are nourishing, feeding our public policies cascade. Any question from the audience? So my question is for all of you, perhaps for Xavier. So a lot has been said about the school. Is there any, is the education department promoting the implementation of all these strategies in vulnerable neighborhoods and schools? Is there any means to support families, vulnerable families? Right, because sometimes it's expensive to acquire skills, computational skills. So how can we contribute to supporting vulnerable families so that they have access to digital technologies outside the school? So as you said before, what we call the local educational plans are an important tool, and then we have other programs, other community programs which focus high complexity schools where many vulnerable students sit, and they have financial grants to participate in extracurricular activities. And according to many research, of course, off-school is a source of inequalities. So in some schools, they are precisely organizing workshops, off-school workshops and seminars on robotics, for example. And of course, all vulnerable students can participate. From the public administration, from a specific department, the education department, we want to include all these activities during the school time so that all robotics seminars and creative thinking seminars are included in the official curricula so that they can be part of the curricula. Once again, we could go back to the website I showed you before, where there is an item where the different elements of the actual curricula are underlined. So I believe Now we have to direct our gaze towards what Xavi mentioned before. I really know Villa and Fontenals High School very well. It's amazing what they do during school hours. And I believe the aim should be precisely to go down this line to ensure that all the benefits stemming from computational thinking and robotics are included in the official academic curricula. And we need to promote the engagement between the school and the community around it. And bring on board as many stakeholders as possible, such as local administrations, city councils, with their own different initiatives to promote computational literacy of and in school, which is especially relevant in vulnerable neighborhoods. In some regions, there is an important network of organizations that focus on leisure and technological leisure. So probably we need to go through a mapping process and see where needs lay in each environment. But again, it's important to be promoting all these activities in the school during the school hours, because it's the only way to ensure equality of opportunities. Of course, leisure enriches life, the life of our students, but yet it's not easy. Sometimes, you know, after school, we all have a life to go back to, right? Even as teachers, we also have a life. Hey, we're human. Yet we are all responsible for ensuring the relevant mobilization of all these resources. It's not an easy challenge to overcome, yet there we are. Hello and good morning, good afternoon. I have a question here. How do you manage? What is the governance model? When you work outside the school, what is the student-teacher ratio? How do you engage with the neighborhood? I've heard it's, you know, a very positive experience, yet we're speaking about vulnerable students, difficult neighborhoods. So how do you manage all this complexity? What is the students-teachers ratio, right? Because when we speak about school environments, perhaps it's a little bit easier, but when you walk down the street, outside the school, how do you engage with families, with the neighborhood, etc.? Well, yet another challenge that we have to overcome in schools. Some schools can count on external teachers for a few hours a week, a couple of hours or 3, so the ratio improves. Of course, when you leave the room, you need 2 teachers every 20 students. So you need to ensure these resources. This is legally binding. Now, if you want to do an activity outside the school and you are alone, it's not impossible. It's not impossible, but yet it's difficult. You need to ask for someone's support, because again, you cannot leave the school illegally or illegally. So of course you need to be with this ratio of 2/20. Because, you know, inviting entities into the school is always a good idea, yet the experience of being out in the street is irreplaceable. It's always better to go out into the bushes, so to speak. So again, it's at the same time trying to make sure that we do not make our peers' life hell. And again, we need to work on the idea of building alliances, like in your center, making the most of your immediate environment. Perhaps in Barcelona things are different because everything is so close and there's so much offer, yet it's all about making the most of the surrounding educational opportunities. You raised MACBA, you've mentioned MACBA and the Elderly People Center. Of course, MACBA, there's only one MACBA. Elderly centers, they are everywhere. So it's about making the most of this network, which can be an institutional or social network. In each environment, in each municipality, things are different, and we need to look for the best possible options, because options are always there, and we need to build external alliances from the approach you mentioned. So the center has to go outside and not vice versa. In Rabat, we've had this experience. It's not the same going out than inviting people in. So again, it's important to go out.
Okay, maybe the parents' associations could also participate and make resources move, and they could also contribute to the associationist fabric. Each territory has its own model, and each one has to structure it in the best possible way. I mean, when the results are so positive, you also mentioned it, when you have such positive outcomes, well, it compensates for the effort. You need to get into the will. You need to actually lose your fear of taking children out, which we know is always a problem for teachers and schools. But once you are part of the wheel, you never want to stop. And this is an alarm. I mean, it's an alert that Victor mentioned. How these spaces that are extracurricular, outside of the school hours, which resources they have on a comparative way. I mean, going to the territory, and in some geographies they have less resources and they're less visible. And maybe we have not yet reached them. And here we have a resource service that will be explained by the CODI lab programs that allow us to encompass and cover other spaces that we would have not been able to reach within the school, or the Catalonian Public Network, which has sessions about educational robotics, in order to have these stages and the idea of small-sized projects. And these are resources we have made available for the whole territory, because we need to give them visibility, so that more schools work with it. We have experiences in which they are working in the field of research work, or with the so-called manufacturing workshops to do the development of robotics and programming skills. And what the public administration will do is to explain what is more visible. And that's why we said it's so important to have a mapping of all of the resources we have. And after the pandemic, well, we will be able to build up bridges again. Because especially in the private field, well, a lot of the projects have actually crumbled down. Well, thank you very much indeed. I think this map is one of the most important driving ideas. And this map exists in many different areas. And it would be wonderful to be able to generate a greater global joint vision, a resource map, strategies, and tools that already exist throughout Catalonia and beyond, because oftentimes, well, it is available, it can be organized, and it can be done. And the wider way of resources we have in Catalonia in the Catalonian language, it would be worthwhile use it. So thank you very much indeed for sharing your projects, experiences, and strategies. And I'd like to thank you all for having come. Thank you. And now, well, we will greet and welcome 4 additional people, 4 additional panel members. And we have 3 people here. 3 of them are in the auditorium, and Rieko will be connecting from London. She coordinates the President Club. Okay, so now we will listen to the third part of the presentation, and with that, we will start the third panel discussion. Okay, give us a second to connect with the panel members and with Rieko. So all set. Let's go for it. So let's start the third panel discussion. We will listen to the experiences in the field of extracurricular education and its work for computational skills. In Catalonia, we have a very strong association fabric and a very strong social and solidarity-based economy. There are many NGOs that are involved in extracurricular activities and leisure time education now. Traditional leisure activities are neither related to technologies nor to computational skills. In spite of it all, some of the institutions and organizations working in this field make an incredible effort. And they follow strategies to fight against the gender bias, which, as Monica said beforehand, is one of the complications we have and one of the problems that we have, especially in the leisure field and not in the school field or the public education field. So now we have a panel discussion, and it's great to be able to share this space with 4 wonderful organizations. The first one is online. In fact, Ruggieko is already online. Ruggieko Moyo from the Spiriti Foundation. She's in London. She's based in London. She will present the COPLAB project, which, as you know, both the Field Foundation and the Collective organization is part of this COPLAB. We implement it in libraries and civic spaces and the school field. The second panel member who will be sharing his project is Noelia Alvarez from the Techno Challenge project. Go ahead, Noelia. And then we would like to invite Isma Monport, who comes from the Pershlamina with an education and social project with a strong technology outlook and a very strong community strategy. And finally, I'd like to invite Hector Gago from the Bofill Foundation. Thank you all. And now, these will be the 4 presentations. So, let's start with Ruggieko. Ruggieko, okay, please be self-managed. Ruggieko will be controlling her own presentation, okay? So if you have any problems, just tell me. I'm here. Thank you. Go ahead. Ruggieko, you have the floor.
Okay, thank you. Good morning, everybody. I hope everybody can hear me clearly and see my presentation as well. Thank you for this opportunity. My name is Ruggieko. I'm just going to, sorry, I'm trying to get my screen. Okay, my name is Ruggieko Moyo. I work for the Raspberry Pi Foundation, a UK registered charity, and I'm the Code Club Community Coordinator for England. So my role is to advance the Code Club program within schools in England. So what is Code Club? Code Club is basically a global network of free coding clubs run by teachers and volunteers for children aged between 9 and 13 years. This age group is not exclusive. It's not exclusive. Children younger than 9 can also participate in Code Club, or older than 13, but our resources are tailored for the 9 to 13-year age group. At Code Club, we really believe that every child should be coding literate, just as basic as numeracy skills and literacy are to, Sorry?
No problem, Ruggieko, we are following you fine. No problem, no problem. Carry on, yes.
We believe that coding literacy should be a basic skill. Just like literacy and numeracy, we believe every child should have the access to coding and should be coding literate if they'd like to. We also believe in creating digital makers and not just digital consumers. So the apps that children love to play with, the animations they love to watch, the games that they love to play online, we believe that children should be involved in actually creating those games and animations and not just consuming them. These are some of our core values at Code Club and Raspberry Pi Foundation. So we have a global reach. We've got code clubs all over the world, over 13,000 countries. Code clubs in over 13,000 code clubs around the world in over 160 countries. So every week we've got a lot of children learning to code in our coding clubs. How does Code Club work? All we need is enthusiastic club leaders. So this can be a teacher or a volunteer, and just as someone who's available to lead a club on a weekly basis. You also need an indoor space. This can be a school, it can be a community venue, a library, just an indoor space where children can actually work with laptops and engaged with coding, programming software. Then what you also need is free Code Club resources, which we provide. All the projects, all the resources, the training, the support that you'll need to run your club, we provide this at Code Club, and it's all provided for free. And the last thing, obviously, you need children to be able to run a Code Club. You need children to actually join the Code Club. So these are the main things, the basic things. We are able to provide all the resources and support for free because of funding we receive from the Raspberry Pi Foundation. So we advocate for clubs run all over the world to also be run for free and not for children, or parents to be charged for joining a code club. And a few examples, from code clubs that that are running in the UK, just a few feedback from their experiences of Code Club. Rachel is a teacher in Dorset in England. She says pupils are excited, engaged, and look forward to coming to the club every week. They are becoming so much more confident in coding. And then Carolina is a child who attends a code club in Surrey, also in England. She says, and she's a girl, she says it's much more fun than coding at school, and nobody's judging you if you make a mistake or decide to try coding something outside the project. And this is the essence of Code Club. Besides actually getting the children to be familiar with coding and programming languages, we really want to foster soft skills, transferable skills that, that will really serve them well in this, rapidly evolving 21st century. I will move along because we only have a few minutes to present. So in order to run a code club, you're looking at committing 1 hour of your time per week. I would add plus or minus 10 to 15 minutes before and after for setting up the club and then for clearing up afterwards. We advocate for code clubs to be run outside of school time and class time. This is obviously because we want to create the environment. We want it to be an environment where children can explore, create, fail, trial, start again. We really want it to be a free, safe place for children to explore and grow. And sometimes the structured environment in a class doesn't always cater for the nurturing of the soft skills. So we really recommend for code clubs to be run outside of class time. Average 10 to 15 children to start off with. You want to start with a small group because obviously there are teething stages when you're starting a code club. Kids learning the projects, you as a club leader learning the projects, and just even handling the equipment, the hardware, how to use the mouse, how to type. So the smaller the number in the beginning is helpful and manageable. Then as your club members and as you yourself become more confident in facilitating the club, you're welcome to increase the numbers. You can also have volunteers. At Code Club, we have room for volunteers to volunteer, and they can support you also to run the club. And any child of any ability can join Code Club. we've got projects that range from beginner level right up to advanced level. So any child can participate, in Code Club. Lastly, the equipment you could use, desktop PCs, laptops, tablets, Chromebooks, all of those you can use for Code Club. And if you have Raspberry Pis as well, those will also work. Okay, this is what we provide for you to run your club at Code Club. All the projects you will need to run your Code Club, we provide for free. Our our projects are developed along 3 main programming languages. That is Scratch, a block-based programming language, HTML and CSS, that's a web development language, and Python, which is a text-based programming languages. So most of our projects, there are other projects developed around physical computing equipment and other software, but our main projects are developed along these 3 programming languages. What do children make when they go through the projects? They make animations, websites, games, apps. They make fun things, the things they enjoy, the things that children like. That is what they make when they go through our projects. And then the other thing that we also provide, in addition to our projects, are resources. These resources are mainly for you, the club leader, certificates to award your learners. We've got a club organizer pack, a first session pack, all with the resources that you need that will help you to get started on your Code Club journey. So if you sign up a Code Club, all these resources would be made available to you for free. Path crib sheets, part of resources, project collections as well are part of resources. And to sum it all up, there's lots of other opportunities that are available to you at Raspberry Pi Foundation when you join Code Club. And you have access to our newsletters, emails, blogs. There's free teacher training. There's a Future Learn course you can actually take to start a learning club. And there's constant support from our Code Club team as well. And this as well is a quick summary of what you can expect to receive when you join Code Club. And if you need to find out anything else, you can either get in touch with us at codeclub.org, or you can get in touch with your local partners at Collectic or Fundación Bofill. I hope I pronounced that correctly. Thank you very much. I hope everything was clear.
Thank you.
Thank you for listening.
Thank you, Rijeko. Stay with us for the questions and answers at the end of this panel. Thank you. Noelia.
Que no está. Vale, buen día, good morning. My name is Noelia. I'm a computer science engineer, and I've been in software development for more than 10 years. And in my career, I've been involved in different technologies, and I'm more specialized in mobile development. And the fields that I've been involved in health, data privacy, and cybersecurity protection of mobile apps. Today, I want to talk about Technovation Girls Initiative. Today, we're going to keep question why this initiative is created, the
the process, the challenge, and the learning that we have accomplished. So why we create this initiative? As you can see in this graph, in pink there are represented the women versus the men, and you can see that in the employed genders, in the fields of engineering and computer jobs, there are below of 10% of women. So the women are underrepresented in these areas. But the future job roles that are in increasing demand are data analysis, IA, machine learning, big data, digital marketing, process automation, and the ones that are decreasing are the data entry, administrative, accounting, accounts, and more factory workers. But the top skills that are expected for the 2025 are skills related with analytic thinking, with active learning, problem solving, creativity, leadership, technology, and programming. So how we can achieve and to succeed with this underrepresented, because the AI is the future, but the woman needs to be there, so the AI not get biased. So, we need the effort of all the business sector, the government, the school academy, and also the social community sector that need to be all involved to achieve. So, Technovation. This is a global tech education non-profit initiative, and it was created in 2006. Here in Catalonia, every year we aim to go to girls from 8 to 18 years old to learn and apply skills to solve real problems in their community. With the initiative, the main goals is to empower girls to become the leader, problem solver, innovator, creator, and change maker. And within that, developing hard skill, but also soft skill. This is our learning program. It's basically in 2 weeks, but we start early, and we start in October for December, when the girls can register and they find mentors. The groups can be from 1 to 5 girls, so also they have the chance to be involved and be a team leaders. We have 3 divisions, depending of the years. From 8 to 12 years are the beginners, for the junior from 13 to 15, and the senior ones that are below are until 18 years old. So when they form the team, the program begins in January, and the main milestone is to identify a problem. They aim to resolve a problem in the community, to solve one of the Sustainable Development Goals, and the main problems that address girls are usually about health, environment, education, equality, and poverty. Yes, and they continue during these 12 weeks. We have a lot of resources, so they can keep learning all they need. So in February, they're supposed to start coding or preparing the prototype, or now also to create a data set for the AI project. And next, they keep coding the application and training the model. But also when the division, junior division and senior division, they need to present a business plan and also an adoption plan. Yes. And the final moment, when they put all together, is final the latest thoughts, they fix some bugs, and prepare the pitch and the technical video that usually also the girls love to do that. And then start the process of the judges take care of the next months to evaluate and give feedback to all the projects that the girls have been presented during that. And they are going to semifinals and finals to decide the winners of the region. Okay, so what we have the challenge? The challenge we have facing as the territory, we are mostly in the Barcelona center, but as you can see in the map below, all the blue are rural areas with less than 200 people. And also we have challenge with the connectivity device, the learning curve, because not all the girls comes from the same background and the same society. Also when we involve schools, they are also potentially drop out after 1 or 2 seasons, so it's a lot of effort in that. And also what we also help, if we can have a recognition, institutional recognition for the people, the teachers that work in the public, so they can collaborate. And the big impact about this program that we have been for 7 years, more than almost 2,000 girls and young women have been involved, more than 38,000 hours, and a lot of mentors and judges, and we have also been almost 500 solutions technical that have been developing for these girls to solve problems in their community. And these also have increased the creativity, the relationship, and the communication also for mentors, for judges and coach, but also girls that are most likely to be involved in a start a STEM degree and to be working in STEM fields. But when you involve with innovation, it's not only locally, you involve with a lot of big community, and that has been for 17 years, and they have a lot of impact and a lot of country in the entire world. And we have been recognized with some different awards in STEM and sustainability program. And this is what the latest data of this year's celebration, that more than 100 mentors and more than 2,000 girls have been involved in this event. And I also want to thank you all the sponsors that make also this possible and collaborate with us. So the girls are really changing the world, so we need to help them. So thank you.
No ho sé, ara ho sabrem. Mira, vaig jo. Bé, doncs ara em toca a mi.
My name is Isma, and I'd like to share with you a project on educational robotics promoted by the Omnium Network in a poor neighborhood around in the outskirts of Barcelona. So we would like to ground a specific experience in a neighborhood, Let me tell you a little bit more about background information. Omnia is part of a network composed with more than 100 contact points. Omnia is a social intervention program that aims at overcoming digital gaps and building and strengthening the community in a vulnerable neighborhood. So we are operating in this neighborhood in the center of La Mina, in the outskirts of Barcelona. It's a vulnerable neighborhood. It's a complex neighborhood, and I am sure that you've heard of them. Yet there's a great deal of opportunities as well. So this year we have implemented 3 educational robotics projects in La Mina, where the Omnium Point is located, One of the projects has to do with training new leaders on robotics, but this has been taken out of the Omnia network, so let me focus on the other two. We have participated in a national contest called VEX, and then a street robotics session in La Mina, in the neighborhood. The target audience is students from 8 to 12 years old. We have been working on this project during the entire academic year, and it's been a perfect forum to implement robotics-related activities with our students. Let me tell you a little bit more about the aims of the project. One of the purposes is to introduce robotics into the school with what we call Aula de Estudio, which is a special classroom for students. We want to introduce new concepts. We want to promote the STEM vocations and using a discovery-based methodology in order to overcome hypotheses, to respond to hypotheses. In the neighborhood, we have a campus, the Diagonal Bezos campus, a university campus, which is or was quite inaccessible for many of our youth. Many of the locals know it's there, but they never get there. So it's a way to engage them, to bring them into the UPC campus, which is a groundbreaking campus. What are the main challenges we have faced? Well, first, we need to build interest. It's not easy to generate, to build interest amongst the local community. There is another challenge, inclusiveness. We need to ensure it's an inclusive environment. One of the main projects in which we take part is the contest, where there is a great deal of competition, so we need to ensure that the value we bring is taken into account. Everyone is welcome, everyone has his or her own role, everyone can participate and should participate, shall participate. So again, yet another challenge which poses difficulties, yet we never care about this. It's very important to promote participation. Then we need to adapt to the reality, to the local reality, because if we compare our reality with other schools' reality, perhaps we lack time, or the way we can approach the contest has to be different because of the specificities of our neighborhood, the availability of the families, etc. So we need to adapt to our reality. Another challenge has to do with funding. Of course, resources, the necessary resources are expensive, so we need to grant the funding of the project. The UPC, this university, is helping us a great deal, taking part in the project. We need to find strategies to keep motivation alive, because of course the competition takes place in February, and we want to keep stamina all year long. So once the contest was over in the past, motivation dropped. And this is when we invented the robotics session, the street robotics session, which coincides with the Cultural Week of La Mina neighborhood. And this helps keeping up motivation in the field of robotics. And yet another very important challenge, which is coordination between different partners, teams, projects, entities. This is an amalgam of entities, is a handful of entities, and it's not easy to coordinate things. So now regarding outcomes, I believe the main outcomes have been mainly the consolidation of robotics programs in the neighborhood and in the town. There are 4 teams, 4 VEX teams, which participated in the national contest, 3 from La Mina and the other one from the other side of the river, which is not bad, right? For a poor, vulnerable neighborhood, this makes us feel already quite proud. We are at our 2nd year, so little by little we want to consolidate our presence in the Cultural Week. We want to consolidate the presence of a robotics space with the participation of HUPRA and UPC. HUPRA is the robotics team in UPC. Now, considering that we're speaking about outcomes, here are the outcomes. Look at the picture. This year we had a spectacular result, which is that we beat it. We won the competition, the national competition. It's not always the case. Oftentimes we are competing not with the last ones, This year we've had an amazing team, these boys and girls, who have been extremely committed, and we were very, very lucky, and we managed to win the national contest, which was amazing. So, lessons learned, many. One, working on robotics with children in La Mina, in the poor neighborhood, is feasible and enriching. We can all participate, we can all have a role. Perhaps not all of us will end up becoming super top programmers, or we will not necessarily work with very difficult code, but yet everyone can program, and this makes things rich. It's very important to have also role models. UPC supplies us with volunteers. Some of them live in the neighborhood because as residents, as a university residents in the neighborhood, so they become points of reference. They become role models, engineers, engineering students. So it's very easy for our students, our participants, to look at them and see them there, right? It's also very important to be playful. Even if it looks like we're only playing, we're learning a great deal of things. And it's very important also to embrace the trial and error loop without despair, without feeling totally hopeless. Then there is a strategy to optimize materials and resources. When we compare our school with others, we realize that we lack resources compared to others. So we must optimize the available resources, and we need to break the taboo of access to university. There's a university in our neighborhood, so let's get into this university. Let's break this glass ceiling for poor people. Last, it's very important to share a very traditional joke that I am sure you've heard. I love playing chess and losing. What about winning? Well, winning would be the bomb.com. So we know that probably we're going to fail, that we're going to lose. No problem. We love losing. We love playing chess and losing. This year it's been the bomb, and we made it. We won the competition.
Què passa? Els ulls, no? Us heu cremat els ulls. No sé on posar-me, per no tapar, em posaré per aquí, d'acord? Doncs, de les pitjors coses d'anar presentant dels últims...
The problem of being the last one is that you have everything you want to say and all the remarks and feedback you want to give to other speakers, and at the same time I want to tell you what I'm here to say. In the Bofill Foundation on February the 2nd, we presented the digital art strategy in a festival. It was chaotic, it was super cool. And actually, there are some pictures that will ring a bell in you. But you know, we are privileged. It has to be said, this year we can feel very privileged. We are at 98% of connectivity amongst our students. During the pandemic, we experienced an extreme situation, but, well, the homework has been done, and we are better off than a few years ago. So when we speak about digital gap, we realize that in the last few months, we've been carrying out more research, and the digital gap, it seems like we are closing this digital gap, but perhaps not so much as we thought, because there are some invisible layers, not the tip of the iceberg, but the bottom of the iceberg, which is difficult to see and to overcome. And many of the points that have been raised today are a good example of the previous. When you give a children a computer, you are not making him or her digitally skilled. No, this is level 2, but then there is a gap in terms of opportunities, which is even less discussed. We need to understand how training or accessibility entails a change in people's life. It's a social ladder that allows us to overcome racial and gender bias and gaps. So we only have very promising projects, but nothing down the pipeline yet. All the work that has been done in UDG, on creative work, etc., but are only, you know, pop-ups. And a lot has to be done down this line, and we have to go beyond Harvard and training. We are in an unknown territory. We need to better understand what happens when we give children a computer. So we have managed to close the first gap. The second one will prevail because, of course, training will always be necessary. But the third gap, unless we pay close attention to it, might broaden. So the more digital we become, the more risks we'll face in terms of data privacy, fake news, the prevention of trolls in the digital environment, democracy risks, etc. So even if we want to be connected and we want to grant accessibility, more and more risks will appear and we need to understand them. In the next years, we want to explore this complex intersection between the different circles, between education, emerging technologies, and social justice, a purpose which is widely shared with other entities like Collectic and many others. And this is why we launched this project on digital equity, digital equality rather. We want to go one step beyond the evident digital gap. Please play with our site and you will find many different resources. The traditional digital gap is easy to depict, and this is why we believe that we need to speak about 8 different challenges. For the time being, we have focused on 8 challenges in the intersection between the 3 dimensions. Challenges related to artificial intelligence, a work line on which we have focused a great deal, libraries in the digital era, disinformation, etc. Today, I would like to focus on computational thinking and our contribution to the digital world in order to contribute to a social change lever. We have a few documents here. Hybrid school, artificial intelligence, of course, is not the topic today, but if you're interested, do not hesitate to take a copy. So we are building this lab, this digital equality lab, in the grounds of collaboration. I've posted one post. We want it to be a co-creation forum led by the community, and many of you are contributing to it. We have launched a pilot on artificial intelligence to see how we can transform our assessment methodologies. We have also launched a pilot on sustainable 3D printing with FabLab. Our partners for this project are here, and for the next academic year, we are designing a new project, which is not going to be easy to implement because, as I said before, we need a community, we need an ecosystem, and we know that we'll get nowhere alone. Actually, in the first presentation, it has been raised. Code Club will be co-led with Eclectic, and basically we want to ensure that computational, creative thinking skills are not yet a granted right in the field of education. Of course, we have a subject on programming, but we know that in order to teach well how to program, we need to work more. Sometimes we are far too based on regulations. One of the girls before said, I like playing outside of the school because I have fun. And here's a risk, which is that if we make things boring, boys and girls will want to leave the school in order to play outside. You know, today, off-school activities are a main source of inequalities because it's private, right? Off-school activities are oftentimes private and expensive. And this is why we want to partner with you all, with the education department, also with the digital policies department, so that the off-school becomes a forum for equality. Our colleague from the UK told us that we've got what it takes. We've got the necessary resources, flyers, we've got everything it takes. Yet, we know that even if we have many free resources, things are not happening. Jody from the department knows it. Having a note per se is not enough. You need to push them forward. So unless there's a community behind, unless there are individuals and time invested, things stand at a standstill. Technovation works because there's a community of mentors, ambassadors, etc. So in Code Club, there's an opportunity, the opportunity to ensure that computational, creative, empowering thinking is made accessible to everybody in our region. And we want to share this challenge with you all. So this lab on digital equality is a shared venture, is a joint venture. We promote hackathons, seminar sessions. You're most welcome because we are overwhelmed. We need motivated brains and a great deal of energy. Many of you have already shared articles and best practices. Please keep doing so. You can also share your project in the lab or in the Project Explorer. There is a project searcher or engine search engine, sorry. So anything you want to push forward, if you are lacking muscle or inspiration, please share it with us. If you feel an inner challenge, if you have an experience, for example, I don't know your experience in La Mina, or today I've met Xavier Rosell and I found the Raval project spectacular. I'm from the Raval and I didn't know this project. So this lonely rider dynamics has to be brought to an end. So please bond with us and with as many relevant stakeholders as possible. Let me tell you about the lessons learned. Well, quite a lot. We are learning in beta still, but we have some red lines and red flags in order to start defining what not red flags, what equality is. The best possible technologies are the ones that make us more human, that help us think differently at the times of profound crisis around digitalization and the use of screens. We also believe that digital inequalities are, in fact, social inequalities. It's not screens that make us unequal or algorithms, it's us. It's the political and social environment that somehow crystallizes inequalities. Schools alone can't solve it all. It's not like schools will end up becoming programming clubs or code clubs. No, schools has a traditional mandate. Today we have, of course, a coding subject, which makes a lot of sense. But of course, we need to have a 360 degrees approach to the school. Neutrality, digital neutrality does not exist. Behind any technology, there's a bias, there's an intention, there's a social reality to be understood. So when we debate about whether we need to work with AI in the school, the answer is clear. Indeed, of course, cautiously, with a great deal of responsibility, but we have to, because the world around is digitalization will be diverse or will not be. Projects like Technovation and many others claim diversity, embrace diversity, and this makes a lot of sense of a school also. Of course, sometimes the schools are very bureaucratic and, let's say, grandiloquent, but we need to ensure that all these empowering logics give us room for, diversity. Open access does not mean equity. The fact that there are open resources does not mean that we are open. It doesn't mean we are balanced or that we are going to transform society. We need to better define the structures, processes, funding, sustainability behind all these resources. Otherwise, the situation will make projects unsustainable. Last but not least, one of the mottos we self-impose us when we say, let's digitalize education. No, the other way around. We need to educate technologies. We need to educate the digitalization. So we are gaining ownership on this motto, and we wanted to share it with you. So I have presented the Digital Equality Lab. You're welcome to be part of it. Please participate to it. And the Code Club, if you believe we can launch joint ventures in a library, in public administrations, please do not hesitate to start to knock on our doors, because we'll be thrilled to start working with you. Thank you very much. So now it's up to you. Questions, complaints, remarks, and also with the audience, with the public that came here today. Let's ask our colleague from the UK. Hello, how are you? Still there?
Si no, li pregunto alguna cosa a la Rieco. Sí, li preguntem.
So, I would like to ask her...
Ah, okay.
Rieko, so what I would like to ask you is about, projects like Code Club, Technovation, these community-based projects that require of volunteers. So what would be the secret sauce for the success of these projects in your region? Why are they so successful in the UK and in Ireland? What is the secret sauce for these projects?
What is the secret sauce? I don't know if there's a secret sauce, really. But I do know that our projects are structured in such a way that children can easily follow them. And in the preliminary stages, when they're starting, so our projects are developed in sets of 6 projects, okay, which is called a pathway. And when they start the first project and they move on right up to the 6th project, they'll be developing, obviously, in their knowledge of the coding skills that are designed for that pathway, but they'll also develop in their independence and creativity as they progress along our projects. So I wish I could show, it's just that the presentation was very limited, but a project will have step-by-step instructions, which children, from about 8, 9 years, if you understand English, they're also translated into various languages. You can follow these projects, and they're very pictorial, and they're scaffolded, they guide a child step by step. But they become less, less prescriptive as a child progresses along the pathway. As they progress, they begin to bring in more of their creativity. Like maybe there could be an option to say, take this step, but maybe you've got an option to take another step if you want to. So they've got more room for creativity, and I think children enjoy that. And as they progress along the pathway, they also become more independent in the way they, tackle our projects and go through our projects. So I don't know if this is something that really could be one of the major things. The projects are obviously fun. They're exciting. They're games. Children love games. They're animations. Children love animations, It's apps that they enjoy. It's things that children actually enjoy and engage with. So I think that is also another reason probably why they are widely engaged with. And then obviously that the resources are also freely available. but not just free. There are free quality resources that are available for anybody who wants to run a code club to use.
Thank you.
I hope that just about answers.
De l'experiència de...
Absolutely, thank you very much. Well, here we have organized code clubs in partnership with libraries here in Catalonia. So beyond the materials you use, which I warmly recommend because we have around 30 to 40 materials translated into Catalan and they are amazing, they are top-notch. I believe another key success factors or winning source is the volunteers that dynamize the sessions. So one volunteer from the academia and one volunteer from the library. And I believe that the one in charge, the representative from the library is the one who engages with the families, is in charge of the enrollment, etc. And we count on volunteers, on students from IT sectors or programmers. And I believe this is yet another success factor, the, let's say, bonding between professionals from different fields, the fact that probably they have previously volunteered in youth organizations in their towns or regions or neighborhoods. So they are, you know, so thrilled they love working with youngsters. So this heterogeneous group of professionals, the volunteer, families, and a professional from a library is a winning combination, is a winning match. And they get, you know, the atmosphere is very positive, according to our experience, and this really contributes to a very positive atmosphere. And here in Catalonia, well, I believe this is one of the key success factors again. Thank you. So before, when you asked people to raise their hands, if they were IT engineers, no one raised their hands, whereas all the members of the public, almost all of them, code. So it's quite interesting to see the split between what means being an engineer and what coding is about, right? So yeah, very interesting. Thank you. Hello and good afternoon. If you don't mind, I will speak about my book. I'm here to sell my book. No, I'm kidding.
The example you have shown us and the question asked by Hector. Okay, the volunteers, how can they be involved? And what you have also mentioned, how can you make boys and girls to come and attend? We have to bear in mind that, as she has said, in principle, the point is to look for places. I mean, you must know that we, as the public administration, I'm sure that the Regional Ministry of Education showed the example of schools. Schools are also places that are available, but we also have facilities for communities throughout our geography, and these spaces can be used for all of these experiences. We have the so-called Somnia pounds with dynamizers. I mean, people who manage the dynamics of group meetings. And, you know, the girl who said she enjoyed more being outside than, you know, out of school, because at school there are things she wouldn't dare doing. So we have these resources, with these facilities, the Omnia network. And if you need volunteers, we also have volunteer points in many cities where there are many groups who are looking, you know, they're just waiting for people to come and look for them. They're available. So you should take advantage of all of these facilities and resources we have in our geography, because that's what they're for. Well, Catalonia is quite privileged from that point of view to promote this sort of projects, because we have a big capillarity in terms of volunteers and facilities. So yes, we will take advantage of that. Indeed, I make a good note of it. Right. For Hector, in the Technovation experience focuses on girls. How do you go about reaching a balance, a gender balance at Code Club? I mean, how do you make sure that there is an equal number of girls and boys in code clubs? This is a question for you, Rujeko.
I didn't hear some of the words.
Shall I read? Yes. How do you make sure that there is a gender balance in your activities at Code Club?
How do you ensure the balance? Sorry,
How do you,
voice is a bit muffled.
how do you make sure?
Was the question, how do you show the balance of
No.
Club?
No. How do you?
Question, sorry, I didn't hear the question.
Okay, I'm repeating the question.
It can be typed in the chats.
Okay, how do you make sure there is a gender balance in your Code Club activities?
Okay. How do we make sure that there's gender balance? There is no. I think when Code Club is communicated, is advertised, or when children are invited to Code Club, there's no demarcation as to whether boys or girls should come. It's open to all children. And what we've found is that in a lot of Code Clubs that are running now, girls always has been an issue, hasn't it? Girls in tech. But what we are realizing now is that we've got more girls actually attending Code Clubs. I've been to visit quite a few clubs around England after the pandemic, and we tend to find more girls than boys in clubs. And I think that's also because of the nature of our projects. We've got a lot of things that probably appeal to girls, to the girls or boys. So I don't think we make a deliberate effort to actually deliberately, there are Code Clubs. There are some Code Clubs that can choose to really focus to go for girls, and some that may choose, if it's a boys' school, maybe it will just tend to have boys there. But usually Code Club is open to any child. And what we've just found is that we've got more girls coming through, as well as children with special needs. We find that they enjoy Code Club quite a lot as well. And I think it's because of the nature of the projects that we've made available. They relate, they connect to both genders, they connect and they relate to children also. They can be accessed by children also with special needs. So it's not something we actually go out and do. It's I think the resources that attract different genders that can participate in the projects.
Sí, per complementar aquest tema.
Let me complement this. I'm not an expert in gender policies, but looking at the job done by Technovation, for example, we have a lot of room for learning. These are spaces that are not only for girls or with a message with female empowerment. We do not have this sort of communication line. There are different things here at stake. The role models. They must see girls, women who are mentors, trainers, volunteers. This is one thing. Something else. The projects respond to the resolution of a project or a learning situation. And to diversify, I mean, it's not about, social challenges for girls and technological challenges for boys. No, we need to diversify the educational offer, and that allows everybody to find his or her own space and motivation. And then I believe there is another interesting element. Sometimes we try to exert pressure, to say that the boy or to have a well-motivated boy or girl. And we need to have indicators through which we actually define some goals. But sometimes when you have an indicator and you exert pressure to obtain a result is when you do anything needed to reach these goals. So beyond these soft elements, in terms of communication or references that must be present, I believe that the promoters of these projects should impose on themselves some gender goals so that it's not part of a bonus. It should be an inherent part of our results, of our outcomes, and of our ambitions. Hi. I'd like to ask the following. You have talked about secret ingredients. You have talked about recipes for motivation to occur on the side of boys, girls, and young people. But what do they actually say? I mean, none of the projects, I mean, maybe I'm wrong, but I have the feeling that none of the projects communicates directly with the target group. And if so, could you share with the rest of us the methodologies you use, the successful methodologies to motivate the target group? Have you asked our young people what interests them and what do they understand by empowerment elements from a digital point of view? Oh, thank you. Well, I can share with you our own experience. We cannot afford this because of lack of time and resources. For this educational robotics project, we only have 1.5 hours a week. So if we have to include all of these elements of creating your own activity and the design of your own activity and what we want to achieve, what we want to get to, we will be halfway for many, many other things. I understand exactly what you're saying, and it would be ideal. And it would be wonderful. But right now, it is just a proposal. It's a proposal we make at the center for these boys and girls. And we have, our doors are open. Anybody can come in. But right now, we are not carrying out this co-creation process to look for commonly designed goals, whether if we want to be part of another initiative action or another type of goal. I mean, above all, this is due to lack of time. 1.5 hours a week with all of the things we want to do. I mean, we do not have enough time. But yes, I understand exactly your comment, and I wish we could actually do that. Yes. Well, I believe a significant ingredient is voluntariness. We cannot always do it, but at least children should feel they are there because they feel like being there, because they want to learn or because they're having a good time. In the extracurricular space, which needs to be educational and of a high quality, but it should not become an academy. Actually, it should not become a school out of school. I mean, so I believe that in this context, in which on the school side there will be learning, better or worse, but it is part of the school system, you know, the computational skills building. This forces us to think about the extracurricular space as a radically creative, empowering, fun, and free space. All of the things that are not allowed at school, I mean, this learning leisure time lab should offer that, and that, I mean, it should be student-centered. We should never forget that.
Girls, what motivates also the girls is that they can be able to resolve and to change, make a change in their own environment. So let's start changing our environment and later change the world. So they can, when they learn, and also they have to be fun because they are from 8 years old, so they are really, so you have to motivate it via fun and introduce to these new technologies. But the way the challenge, the way that they share with the other girls, that empowers and motivates to keep going.
There is an element we mentioned beforehand with Xavier Roussel. I met Xavier this morning, but we talked about this before starting today's session. And he said, okay, the feeling that the participant, the student or anybody participating in an extracurricular activity, what they will do will have an impact on the community and it will be significant. It's not just about having a good time. It's not only about him or her learning about things and developing his or her own skills, but he or she will be able to help the community. And community spaces actually have that in mind. It is a community duty. Something that you will do will have an impact on somebody's life, and it will change for the better a person's life. I mean, solving a community problem, solving a social problem. And I believe that in the field of computational thinking, beyond thinking about doing scratches or whatever, I mean, we have to ask ourselves, why do we do what we do, and how important will it be for the world? So this responsibility link, this emotional responsibility, compensates for the leisure time activity, this community responsibility side of things. Any further questions, please? Well, thank you very much indeed. Thank you, Rojeko. Thank you, Hector. Thank you, Ismael and Noelia. Thank you so much for sharing your projects and experiences with all of us. Thank you so much, Rojeko. Thank you.
Doncs anem tancant al matí.
Let's finish off. We have listened to a very wide diversity of proposals and experiences and political and institutional strategies. And given that we're leaving this room with a lot of ideas about how to change our actions on the territory and how to transform our environment, I believe that now we will be living with a clear idea about, do we want computational skills to be a fundamental right, to learn how to program, to learn how to have a well-informed opinion, to make decisions about the technology that affects us on our everyday lives? Should it be a fundamental right of people? And we can work with young people, you know, formal schools and formal and informal teaching. And we need, I mean, we have a commission to build up and improve the general vision of this global map about the resources, the tools, and the experiences that already exist from the 3 points of view: formal education, informal education, and non-formal education. So we have a lot of work to do, a lot of homework to do. Thank you ever so much for having come, all of you. Thank you.